we're talking about regression analysis. It's a word that I don't know if many of you have heard, and I will also try to do justice to this topic, given that when I first learned about it, it took me a year to understand how to use it. So hopefully for all of you, it'll be a lot quicker, and it's doable in the coming 50 minutes. So the idea of so first, before we go into what a regression analysis is and how you can use that in statistical inferencing, let's just remember or recap what we did yesterday in the sessions. So if you remember, we were in the first place trying to test a hypothesis of a population of interest. Now again, we're dealing with a population here. So in practice, we cannot get data and test the hypothesis for the entire population, have to rely on a sample, which means we are bringing in two sources of uncertainty. First one is, of course, the fact that we're using a sample to derive information for the entire population, so generalize information from a smaller group of individuals to a larger group of individuals. And then the second source of uncertainty that we have is, of course, that we are choosing the sample or selecting a sample, and that might bring in error, which is a sampling error that we consistently talk about. And how do we try to counter that? Statisticians made our job relatively easy there, and we use inferential statistics. We use the tests that they have created, and specifically we talked about the t-test, which we then use to compare against given confidence intervals. Again, just to explicitly account for the sources of uncertainty in our testing of the hypothesis. So quickly, again, going through the steps. First, we define a null hypothesis, right? Again, remember, the null hypothesis is what we're trying to reject in our case. So we always say that there is no difference as the null hypothesis, or null effect, as you'd say it. Then we talk about our test statistic, okay, which we are calculating. I told you there were multiple tests. In the end, we calculated on Excel one statistic, which was the t-test, or t-statistic, sorry, using the t-test. And then we define or set our confidence level. So far, we've always been using the 95% confidence interval. It could be that you are wanting to be more confident in your results, so you decide a 99% confidence interval. And all of these intervals are something that you set for yourself, then define the critical value associated with it. If you remember, for the 95% confidence interval, when we are looking at t-test or the t-distribution, normal distribution, where from which the t-test is on which the t-test is based, the critical value was 1.96, and we were always comparing against 1.96. However, we did not use the t-test to conclude on whether or not we accept or reject the null hypothesis. What we used was the p-value, and the p-value basically is a statistics you derive from the t-stat, and it simply is, or very intuitively put, not technically, but intuitively put, it's simply the probability of being wrong when rejecting the null hypothesis. So what we try to see is if our p-value is low enough, we have a high confidence in rejecting the null hypothesis. So for everyone to remember, you always need a low p-value to have high confidence. So again, the relationship is inverse here. And what we were comparing against, the p-value against, was always the significance level, which is again now the 100 minus confidence level. So if 95 is your confidence level, 100 minus 95, 5 is your significance level. So if you remember from our example, the p-value was about 3.2, which is lower than 5, which is why we were confident that, or 95% confident when rejecting the null hypothesis. Or our null hypothesis was rejected at the 95% significance level. Okay, good. So now we've done a short recap of what we learned yesterday in terms of statistical inferencing and so on, and how you can interpret a test result. The problem was, which I didn't go into very deeply yesterday, is that t-test is often not enough to establish causality. In any program, you can't just assume that, and when we were looking at a hypothesis, we were looking at education and impact on income. But it's not just education that impacts income. In part, we are interested in the gender of the individual. Where did they start off with? Were they better off in the first place? And these other factors also could explain a difference in income. So one of our colleagues here asked whether the result we saw yesterday, that is the income level of individuals who had studied or who had completed secondary education, being lower than the income of individuals who are completed primary education only, was correct or was, reliable. And while technically this is not reliable, there could have been other factors that could explain this difference. Or when you include these other factors, they change the result. And that is why we use regression analysis. And now this entire session will be trying to include these other factors into your analysis so that you are able to understand or get a more precise and correct effect between your variable, which is education on income. So to give you a very brief overview of what we're going to do, we're going to talk about what a regression is. It's going to be a relatively simple, intuitive explanation, not too much math, a bit of math. So I hope you have brushed up on your algebra. And the idea would be that we try to quantify the relationship between variables, so between income and education, and while controlling for other factors. We will then talk again about statistical testing, what we talked about yesterday, the entire p-value story that I just explained in the past 5 minutes, and apply this now to regressions. And then finally, we'll try to understand the logic of regression analysis. And again, I've briefly talked about it already, which is controlling for other factors that confound the relationship that you are interested in, or try to sort of bias the relationship that you're interested in. And then finally, we talk about not just a simple one-to-one regression or bivariate regression, but we're talking about multivariate regression where we can introduce as many variables or as many confounding factors as we like. I'll try to also talk about regression analysis and causality. However, I think this would be more suited for the session that follows afterwards, where I'm actually able to show you the results of a CIE method where regression is applied. Okay, so what is a regression analysis? Again, as if you remember, we were looking at the link between education and income. And we had simplified our measure previously, wherein we dichotomized it, or we created into a binary variable. And the variable was simply saying, did you complete primary education? Did you not complete primary education, right? And based on this, we were testing that those who've completed and those who've not completed, whether there's a difference in their income. And our null hypothesis was that there is no difference in their income. Now, let's say we are interested in not just the dichotomous variable of whether you've completed primary education or not, but now we're interested in the years of education completed and how does that affect income. So effectively, if one were to look at this graph, you would just put years of education here. So this is 0 years of education, if you remember, and then 1, 2, 3, and so on until you go to the highest years of education you can achieve or find in your data set. On the other side, you, of course, graph your income. Of course, this is 0 income, and then you continue going upwards all the way to whatever the highest amount is in your data set. Let's say 200,000 Ugandan shillings in our previous example from yesterday. Right, so knowing that we have this graph here, we generally expect that there is going to be a higher income level for every year of education that you've gained. And what regression analysis will allow us to do is tell us exactly how much more income you can expect for every additional year of education that you get. So moving each step along the way, you can then quantify exactly the gain in income that you have here. again, on a more linear trend, but I'll talk about that in a bit. So again, let's start visualizing we're looking at. So we're looking at 17 people in our data set now, or again, we've moved away from 10, we're going to even higher numbers of 17. And we have information for these 17 people for the years of education. So here you see our lowest or minimum years of education is 2, then 3, and 4. So the lowest is 2 years of education, whereas the highest goes all the way up to 15 years of education. And associated with that, for each individual, we also have the monthly income. And again, here, the lowest income that we see is 500, and the highest income that we see is 1,600 here, I believe. Yes, exactly. So this is how sort of your graph would look. So nothing around the zero point, but further along. And what we want to do now is visualize this on something called a scatter plot. So this is a scatter plot. I already explained what the X and the Y axis are. As you remember, the minimum years of education we have is 2, to which we associated 500 units of monthly income. And the highest we were looking at was 15, which was around 1,600 units of income, right? And so what we've done is all 17 individuals are now plotted along this education and income axis, right? What do you see here? This is basically showing us that there is a positive relationship. How do you say it's a positive relationship? Basically, an upward slope is exactly what tells us that this is a positive relationship. So the more years of education you're having, the line is moving upwards and not downwards and not horizontally. So what we can see here is that we tend to observe that for higher values of income, education, or higher years of education, we observe higher values of income. And now what regression will allow us to do is first, in the first place, quantify the relationship between the two variables, which is to say, we will be able to measure how much our income will increase when completing 1 year of education. So for this guy to have moved from 2 years to 3 years of education, what would be the increase in income for this person? And then the second aspect that our regression analysis will allow us to do is to gauge whether this relationship is due to chance or whether it's actually significantly different, and we are confident about our relationship existing. And here is where we will rely on statistical testing. Because now all of you are experts in statistical testing, this part will be easy, so I'll try to focus a lot more on this part. Right, so now talking about our relationship. How did I already briefly hinted at it, so now I've put it in there, and this is the line that I put to sort of quantify or sort of visualize how the trend is looking. So as you see, I said already, with more years of education, we observe higher levels of income, and this line is showing you exactly that. You see it's moving along the points, or is moving basically along the same trend as where the points are. And so we've fit a line to our data points. And this fitting of the line to our data points is basically what the most simplistic explanation for a regression analysis is. And now you might be wondering, why a line? Why not a curve like this or a curve like that? This curve might also fit here. And then secondly, if I manage to convince you that a line is nice compared to a curve, why are we going for this particular line? And again, we just briefly talk about both of these things in the coming slides. So why are we going with a line? Intuitively, as you might have understood, a line is simpler than a curve. Even if you are intending to go to your friend's house, you try to take the most direct route to get there. You don't try to take, you don't reroute yourself through, various other extended ways. Again, naturally depending on the person, right? So if you want to go the simplest way, it's always a straight way. If you want to go a nicer way, you want to pick up groceries along the way, then you take a curve and you go through a different route. However, intuitively, if you're running out of time and need to get there really fast, you could take this straight a line as possible. And that's basically the same intuition that we're trying to apply here to understand as simply as possible what is going on in our or how to explain the difference between or the relationship between education and monthly income. And so here we start our short math lesson. If you recall your algebra, we often used to look at equations like this, where you had one annoying y on one side and then a plus bx on the other side, or a plus x on the other side. And this is simply the logic behind a regression as well. And so I'll try to sort of put in the logic of our hypothesis into this small equation here in the following slides. So what we try to do with our x is to see, which x again is represented by our x-axis here. So it's basically the years of education, right? So if we increase x by 1 unit, so in our math examples, if it was increasing from 2 to 3, y was changing by a factor of b when adding a to it. So you have to add to a the value of x by a factor of b, right? So this was how we were doing it, which means that for our case, if income is increasing by 1 year, education is increasing by 1 year, income will increase by a certain given constant value. And then on top of that, we will add a factor of the years of education. And this factor is basically defined by this line. So in our case, this factor is basically called, in regression, this factor is basically called the intercept. As you see, this line is not coming all the way to 0, 0. So if it was coming at this point, your intercept would be 0. However, it's actually intercepting the y-axis at this point, which is slightly below 500. And this is why this line is basically intercepting at 324. So for someone who has 0 years of education even, their expected income is not 0, but around here. This is simply what the intercept tells us. And then we are interested in the slope of the line, which is basically the b that we were previously talking about. So now I've just replaced the b with a different definition, which is the slope of this line. And this is now again coming back our regression line that we are talking about. So let's see what happens if we increase education by 1 year. So this is a 1 year increase in education. And what it shows us, or what this line shows us, or what you can see here, is that income has increased by 86 units. What does this tell us? Basically, if you want to get the monthly income for any individual along this line, all you have to do is multiply their years of education by 86. Then add the intercept term, and voila, you have the education or the monthly income for this individual along every single year of education you observe in the data. So for 2 years to all the way 15 years, you would see what their education, or you could predict, so to say, what their education would be. Right. So now I'll give you an example of the same prediction, which is say, could you predict how much income someone who has 10 years, sorry, is someone trying to speak? No, okay. Exactly. So if we were to predict how much income a person with 10 years of education is expected to earn. So if we look back at our equation where the y was just monthly income, right? The x is now years of education. And now we have the slope of the line, which was 86, as well as the intercept. What do we have to do? Simply put 10 here, which means this gives us 86 times 10, 860. add 860 to 405, we get 1 to 8. No, wait, 1265. We get 1,265 as the years of income for someone who has 10 years of education. And this is basically the quantification of exactly this line. What you will notice is that in your data set, someone with 10 years of education is actually shown to have higher income. So what I'm trying to always remind people is that this regression will try to give you a best fit along your years of education and monthly income. So it doesn't mean it's giving you an accurate fit, but it's giving you a best fit. In which case, this would be, let's say, for some individuals, you don't have the monthly income, but only the years of education. So at best, you can predict what their income would be, you know? And this is sort of coming back to when we were talking about outliers before, when we were talking about imputing the values, and we were saying we should replace a very high value with a new value. Regression, for instance, is one of the techniques we use to impute the value. We predict how much the income would have been given the years of education based on the entire data set that we do have. And this basically is a prediction that regression allows us to do. Right. So I hope so far what we've understood is what a regression line is doing and why we go for a line instead of a curve, right? Which is now curves are more non-parametric analysis, which we are not going to here at all. But now we talk about why this particular line, or the logic of how a regression works. And I already briefly mentioned it several times here. The idea is we could fit several lines along the same set of data points, right? We could put this purple line here, we could put this red line here, whereas we chose to go for exactly this turquoise line. Why did we go with the turquoise lines? I hope some of you are already thinking about this, but the idea is that we do not choose this line randomly. The line is basically the best fit that we can find to our data points. So it's that exact line is basically the one that comes as close as possible to all the points that we see in our data set. And in technical terms, it's a little more complicated because you're not just trying to reduce the distance, but you're trying to reduce, trying to understand exactly what. Anyways, in technical terms, it's a little different, a little more complicated, but here in this specific example, let's just stick to the idea that we're trying to reduce the distance between all of these points and one given line. And this line is what our analysis shows us is the closest to all of these data points. So again, as I said, technically, we are trying to find it with the help of something called ordinary least squares. That method, of course, tries to minimize the sum of squares, as I said, a more technical term. However, we don't look at that. If you're interested in this, I can recommend several econometric books about it as well. Right, so again, the reason why we went for this particular line is just because it's the best line, allowing us to have the least distance between all of these points under certain conditions. Now, these conditions, again, I will not explain. Again, much more math than I wanted to, so let's move on to already, given that you've hopefully understood the intuition behind regression, let's move on to understanding what we've talked about before we move on to clear examples about it. Right. So first and foremost, we are interested in the relationship between Y, which is income, and how it's affected by education. And in particular, we're interested in the year of education, so every single year of education. Since Y and X have many values, we try to represent them through a line, which is the simple formula of Y equals to A plus BX, where X is your years of education and Y is your income. There is an intercept term and a B, which is the slope of your line, and your intercept is where basically your line cuts the y-axis. Right, so what regression analysis allows us to do is find exactly the values for A and B in our case. And again, lastly, we chose a line. It's the most simple, intuitive way to express a relationship. And secondly, it's the choice of this particular line is only because it's the one that comes closest to all our data points. And that effectively is what regression is all about. So now our question is, starting with how to make sense of the results from a regression analysis, or what to make of the results from our regression analysis. And so we try to go into the interpretation and statistical testing that we talked about yesterday and how it works within regression analysis. So coming back to our lovely line, what you observed in this case was that there was an upward slope, or it's a slope going more, let's say, towards the northeast. And this is a positive relationship. If the slope was consistent, which is that to say that regardless of whatever years of education, let's say we only earn 1,000 units of income, this line is horizontal, which means that there is no impact of the years of education on monthly, or no relationship between years of education and monthly income. If for some reason we were to observe the opposite, which is to say, as our years of income are increasing, our years of education are increasing, our income is decreasing, this line would be downward sloping or looking something like this. However, in our case, obviously, we noted a positive relationship, which was for every year of education, we had 86 units more of income. But again, we are using a sample of 17 individuals for perhaps explaining something for a much larger population. And so how confident are we about these results? And therefore, for this, we need a statistical test. So given our relationship that we, as I said, we express through a line, and particularly in math through this this equation, we are now trying to find through our regression these parameters, A and B. And these are, so to say, in regression called estimates. So we are estimating our A and our B, and effectively regression would give us the A estimate and the B estimate. In our regression, we found, or after running our regression, we found that our A, or our intercept, is 405. So for 0 years of education, which means that this entire second half is missing, you will still find 405 units of income for any individual in the sample. And then adding every year of education, you simply have to multiply that year by 86 to get the monthly income. And this is what our regression shows us is the relationship between years of income and monthly years of education and monthly income. And now we talk about the reliability of this estimate. Again, we now have to hypothesize what this relationship could be. We have to calculate the test statistic. We have to define the p-value associated with the test statistic, again, based on a set confidence level, and then conclude whether or not we reject our null hypothesis. So what question are we asking ourselves here? Basically, now our null hypothesis has slightly changed because we're not just looking at primary income or not primary income. We are basically trying to just establish about the positive relationship between income and education. So in our case, the null hypothesis will be formulated slightly differently because we're still looking for no effect, no difference, but here we are hypothesizing that there is no relationship between income and education in our population. If you remember, no relationship would just be a straight line, as I showed on the graph. So regardless of your year's education, your income would stay consistent across. And this would be the null hypothesis that we are trying to test and potentially reject. How this is defined in regression is simply that the true value of the parameter B in the population is 0. The parameter B is defined from the sample, and we would like to understand if the true value in the population is actually 0. right? So take the results from our sample, apply it to the population. Would we reject our hypothesis there? Knowing our null hypothesis, we do a testing on the side, and I find out that the p-value is actually something like this. So it's extremely small, right? And remember, the smaller the p-value, the better it is, the higher the confidence we have in our rejection of the null hypothesis. If you also remember, I said always take the p-value, multiply it by 100. Even if we were to multiply it by 100, which means removing the last two zeros, we will still remain with a value of around 0, which means we can decide that we can reject the null hypothesis at the 1% significance level or with even 99% confidence. We definitely can reject it with 95 and 90% confidence as a result, right? So what do we conclude from this? We conclude the parameter beta is statistically significantly different from 0, not only in our sample, but also likely in the population. And we can say that with more than 99% confidence even. So what we can conclude is that there is a statistically significant positive relationship between income and education in our population. Right. So now let's move a little further and talk about a few pointers related to regression. So here we generally focus only on the parameter B, which is the relationship between income and years of education and income. However, just because this interests us most doesn't mean that we can't test out whether the parameter A, which was the intercept, which was 405, is actually truly equal to the parameter in the population as well. Again, our null hypothesis in this case would be whether parameter A is truly equal to 0 in the population, and we will set about rejecting it. The second thing is that for regressions, most statistical software will provide you the p-value already. Again, also, so it's not as complicated in or it's a little more complicated in Excel. If you were using other software such as eViews or Stata or SPSS or R, whichever one you're using, it would provide you with a p-value for the significance level or a significance test of each of your estimate parameters. So not only B, but also A. And then technically, what we are using in this case is always still the t-test. We are assuming a normal distribution, which is what the t-test is based on, and it's basically the same type of test we are using, and we talked about yesterday when we were calculating just simple means between two groups. Right. So just to give another example, let's say that we're trying to estimate the true value. Again, our null hypothesis was that we're trying to estimate whether the parameter beta in the population is 100 instead of 86 previously. And with our data, we find that the p-value is 0.12. What do you conclude? Again, you have to take this parameter 12, multiply it by 100, and what you find is that it's 12, which is higher than 10, which is a significance level at 90% confidence, which means that even with 90% confidence, we cannot say it. We can say it only at most with 87% confidence that this is the true value of the parameter, or is not, or basically you can reject the null hypothesis and say that our value is similar or in the parameter is not 100. Well, in this case, it's 100, but if it was 0, is not 0. Right. So just again recapping, we have been able to now quantify the relationship between two variables. So how much does income increase when we increase education by 1 year? And we've been able to gauge whether this relationship is purely due to chance, or we can be statistically confident about our results and at what level of statistical significance we can do it, again, through the help of statistical testing. But now we're coming to the big question, and that is, sorry, just a second. And that is basically, why are we using a regression analysis? So in the previous case, we were always considering the link between education and income, right? But and we were always testing our sample data, and we were using a t-test to compare this, right? Given all of this, let's say now we have a p-value of 3.0319 multiplied by 100. We know it's 3.19, which is saying that we are comfortably rejecting it with a 95% confidence in our results. Exactly. So again, not to repeat myself, what I just want to point out is this last sentence here. So having rejected the relationships with purely just income and education, or education and income, we cannot confidently say that basically education is the only thing that affects your income. We all know that besides education, there are many other factors that might be associated with a change in your income, or even might be directly causing it. And this is basically what also you call confounders. Basically, other important factors that drive this difference. So if you remember, again, when we were looking at the case of 10 years of education and calculated 1,265 as the monthly income for someone with 10 years of education, right above the line, there were two dots, and both dots showed different levels of education, which means there are other factors that explain why one individual was, say, at 1,300 and another individual was at 1,350. And these factors are called the confounders, or confounding variables in our regression, simply because they blur or disturb the relationship of interest, which is between education and income. The second point is the reason why they're problematic is not only because they affect, these confounders can not only affect income, but they also tend to affect education. And so they're affecting both aspects at the same time. So let's think of a few examples in the case of education and income. What other things do you think affected your, for example, income earning? In our particular case, let's go with one variable or one other confounder, which we think is parental income. So the level that you started off with. So knowing that we think this is a confounder, what we need to do is we need to establish or get the data for the parental income for each of the individuals on top, right? And then first we need to understand whether or not this is a confounder in our case. So let's do it in the most complicated manner so that it's a little clearer, and try to fit a regression line on between parental income and education, and parental income and your own income. So the first case, as I show you, is now putting on or trying to fit a line between parental income, which is your x-axis, and your monthly income. So what we've done is change education here with parental income. And again, what you see, so now the points are a lot more spread out, but what you see here is that parental income is again positively related with monthly income. The line slopes outwards. Let's say that for each increase or unit increase in parental income, your monthly income increases by 0.35. So about a third increase. So a unit increase in your parents' income leads to a third unit increase in your own income. This relationship we find is now at the p-value, or has a p-value of 0.22, again 0.022, and multiplying this by 100 gives us a value of 2.2. We can again comfortably reject it with 95% confidence or at the 5% significance level. Only reject the null hypothesis, which is to say, accept the fact that the estimated value of our slope is actually different from 0, which is our null hypothesis, saying that there is no relationship between parental income and monthly income. So we see a significant relationship between parental income and your own income in the population even. Now, let's look at the other variable of interest in our case, which was the years of education. So now here we have the years of education on the y-axis, and we're trying to estimate what is the relationship or effect of parental income on years of education for yourself. Again, while plotting these points, we observe another upward slope here. And here, the estimated value of the parameter is, or the slope is 0.003, which means that for every unit increase in your parental income, your years of education increase by 0.003. So a very minimal increase, which if, for example, you were to say instead that your parental income would increase by 1,000, so you have to multiply this by 1,000, your years of education would increase by 3, right? So it's actually not such a small effect. It looks small here, but technically 1,000 unit increase in your parents' income is actually a 3-year increase in your own education. And the p-value for this is 0.068, which is basically multiplied by 100, 6.8. Compare it to our different confidence levels or significance level, we can only accept it with confidence at the 90% confidence level, right? But still, we are at least 90% confident that there is a relationship between parental income and education, which means that parental income is indeed a confounder. It affects not only our own income, but also the years of education we actually end up getting. And so what we are trying to do is that while our first regression is just showing us that there is a positive relationship between education and income, we need to account for another confounder, which is parental income here, which is now significantly correlated with both income and education. Of course, there are good theoretical explanations for this as well. You know, your parents are more well off, are able to send you to a good school, do not require your help in farming activities. You don't drop out of school, you continue your education. Similarly, you're likely to have gone to a better school and have better chances of getting a better job and thereby have higher income, right? So there are also theoretical concepts that can explain this confounding relationship that parental income might have on your own income and education. And this is probably the reason why we need to account for income in our analysis or in our regression analysis. So far, we've only talked about a bivariate regression. So if you remember, the simple line only included a y and one x, which was 2 variables, or a bivariate regression. And now we want to include a third variable analysis, which is parental income. So how do we do that? And this is where we talk about multivariate regressions. So to talk about multivariate regressions, we come back to our basic math example where we were looking at the relationship between our x and y with our intercept and our slope of the line, right? Now, a multivariate regression, what it would do is, again, draw a line, but not just between these two variables, but also allow you to include additional variables on top. And in this case, one more x variable, which is parental income. So while a multivariate regression or a bivariate regression looks like this, a multivariate regression would look something like this, wherein here is your years of education, impact on income, but also you now include parental income on term and its impact on income as a variable. Naturally, the slopes here are different because we saw as in the different graph that the relationship between parental income and years of income was different. It was 0.3, whereas the relationship between years of education, your years of education, and parental income was 86. So there are different slopes to these lines, but what regression allows you to do is slope each and every one of these relationships, right? Or put a b value to each and every one of these relationships. So this is what our new regression would look like. So it'll be y equals to a plus b1 x1 plus b2 x2, or simply monthly income as related to education by a factor of b1 and parental income by a factor of b2. Okay, so now we just simply have to carry the intuition of our bivariate regression to a multivariate regression, right? Again, simply every time you see a positive slope here, it means we have a positive relationship. If we see a negative coefficient here, so here, of course, we always put a beta, a plus here, but your b can be a negative value, which means that you have a negative relationship between, let's say, education and monthly income. And so your slope or your B is simply giving you the direction of your relationship. You can test each and every one of these parameters or estimates for these parameters that you've drawn on through your statistical testing. Again, we can assume a normal distribution and just run a t-test for each and every one of these. Through the method of OLS, you will get the best linear approximation for all of these variables and are able to run your regression. Sadly, because now we're using 3 different variables instead of 2 variables, it's hard to visualize it through, for example, the scatter plot or the simple bivariate regression line I showed you before. In principle, as I said, here we only added 2 variables. You may add as many variables as you want. In practice, if you've done this before, you would remember that there is limitations to this. So if your entire sample is 17 observations and you're adding 17 variables to explain your monthly income, you will run into a problem. So the larger the sample size, the more number of variables you are able to add, or the more number of confounders you are able to add to explain your relationship. And this is sort of the concept of degrees of freedom. So how much freedom you have to sort of say run your regression. And then naturally, please don't just put anything you like or anything you have data on. So if this is telling you if you have data for each individual on the number of cups they have at home, this is not something that you should add to the regression just because you feel like it, but it should have some sort of theoretical underpinning to it. Right, so just going to our t-test again. Now we've run our bivariate regression and we have a p-value underneath in parentheses. This is how you, for example, will also see it in a report, either underneath or on the side. And what you see here, the p-value was extremely small at 0.000, right? Now we start including other factors, which is the confounding variables. And now we've included, in this case, the parental income. What differences do we observe here? First and foremost, our intercept has changed. So now, including parental income, we see has reduced our intercept term, which means that our line is intercepting, or our line, which was previously intercepting at 405 units of income, is now intercepting at 324 units of income. Secondly, we see 80 is still, so it's still every year of education increases your monthly income by 80 units, which is similar to 86, but lower. And finally, we see that every unit of parental income increases your monthly income by 0.1. So what you see here again, if you run a bivariate regression, you will get a different coefficient. So here 80 instead of 86. And 0.1 instead of the 0.3 that I showed you previously, and we'll give you this kind of a relationship. On top, our p-value for education and monthly income is consistently strong here, which means we see a statistically significant difference nonetheless. So we can still reject, because the p-value is so small, we can still reject a null hypothesis with over 99% confidence. However, for parental income, this is not the case. What we see with respect to parental income is that the p-value is now 11.5, which is higher than 10 significance level, and we cannot reject it at even the 90% confidence level. Reject the null hypothesis at the 90% confidence level. Okay. So what it tells us is that when controlling for parental income, we still observe a positive and strongly statistically significant result between education and monthly income. The only difference is the parameter is lower than before. Alternatively, for parental income, there is still a positive relationship, but this is not statistically significant at the 90% confidence, 90% or higher confidence interval. And if you remember, also the parameter has changed. It was 0.3 previously and has now become 0.1. So basically, the goal of multivariate regressions is to understand how variables behave jointly, in combination, or indeed just through as pairs in our relationship of interest. We can add, for example, another variable here. Let's say we add gender of the individual, which we also think could be a factor that confounds their years of education, their monthly income, and so on. When we now try to visualize this, you would see all the red dots here are males and all the black dots here are female. And what we observe that visually we see that men tend to be on this section of the graph, which is higher years of education and higher monthly income. Women, on the other hand, tend to have fewer years of education and less income in general, it appears. There's still a positive trend, but on different parts of the graph, right? So our data tells us that, okay, look, when you take your sample and divide it by men and women, indeed, men have higher incomes, and it's statistically significant at even 99 and at the 1% significance level. And if you look at years of education, again, it's a massive difference, which is again significant at the 99% significance level. So is it a potentially confounding variable? It's potentially a confounding variable. Let's add it into the regression and see. What we see here is when adding it on top of parental income and education, there are two aspects. First and foremost, these results did not change. So it's still 324, it's still 80, and it's still 0.1. The only difference being that the parental income now is slightly even less significant now, statistically significantly different. Gender, in fact, on the other hand, has a negative relationship, with here gender being if you are a male, you have a negative relationship compared to being a female, and on income. And on top, it seems that this result is not statistically significant. If you look at the p-value, 0.990 multiplied by 100, we're looking at 99% p-value. This is so high. At no confidence level can we accept that this result or this estimate that we have done of the relationship between gender and monthly income is valid in our population. What this also means is that gender is not adding any valuable information to our data set, to our regression, and therefore be parsimonious and drop it. The guiding principle here should always be if you're adding variables and one of them is not adding too much to your result, it's simply stealing away your degrees of freedom or the freedom to run your analysis given your sample size. Conceptually, you should, even if it conceptually makes sense, drop it. The reason why this is happening is probably all the information that is contained in gender is potentially already captured by other variables. So it's something of the difference in genders is already potentially captured by, let's say, parental income or education in this case. Please remember, this is just a hypothetical example we're trying to show you. This is potentially not what you find in reality again. So if adding a variable leaves you with very similar or stable results as it was before adding it, remove it from your analysis. Finally, I just take a minute to go through the example that we had from the first day. Remember, we were talking about the youth vocational training program. We had 14 youth centers with the aim to economically empower disadvantaged youth. And now you're asked to quantify the effect of the program and you want to use regression analysis on it. Remember, what you have to think about is what factors do you wish to control for the relationship between having the program or receiving the program and income, because you actually are interested in the relationship between the program and income. Previously, it was your education and income. Here now it's still the impact of the program or the effect of the program on income, right? So you need to get this data. You take a large representative sample of young individuals in the area and conduct a rigorous data collection, clean your data, accurately measure income. You then also get other information for these same individuals, such as gender, age, parental income, education level, previous employment, you think might confound the relationship between your treatment, which is them receiving the program, and your outcome of interest, which is income. You take a regression analysis, and having done this regression analysis for you, we find that the program leads to an increased average monthly income by 300 USD, which has a p-value of 0.01. 1 is your p-value if you compare it to the statistical significance level, which means you can accept or reject the null hypothesis that there is no effect of the program on income with 99% confidence. One last thing that you need to remember, however, is while so far we've only been talking about program participants and not talking about non-program participants. So how confident should you be in telling your client that they should expand the program because you find a 300 USD worth increase? This is the problem of causality or attribution that we were previously talking about. While regressions are allowing you to control for confounders, they don't extend to causality. You need to understand that the concept of causality can only be established when you have a CIE method, when you have the same information from individuals that are not part of your program, so who do not participate in your program. Other factors such as motivation cannot be measured. You don't have the data for that. And that's where a CIE method will ensure that you account for these differences and then are able to express your relationship between the treatment, which is the program, and income in a more causal manner, or attribute the increase in income to your program itself. Right, so having done that, I would like to conclude the session with 3 minutes over. Before we go into the break, I see that the break is till 11:20, which means we have now about 12 minutes to basically take rest. You can scroll through these slides because I will leave them on if you have any other further questions, and then we'll meet in about 10 minutes at 11:20, 10:20 or 9:20 your time. Or 12:20 your time, and talk about the case study from Ethiopia. Thank you. Right, so I hope everybody can see the slides. Yes, I also would like to thank my colleague Bethlehem, who is joining here. She's the lead investigator on this program. As I already briefly mentioned, this is the Eutf program. Bethlehem, if you just want to say hi to everyone very quickly, please feel free to do so.
Yes. Hi everybody. So my name is Bethlehem, and I'm a monitoring and evaluation specialist at C4ed, based in Ethiopia. And yes, I'm the project lead of this project, and I'm happy to be here.
Yes, so the reason why Bethlehem is here is that while I will try to explain the concepts that we've done the training on today in the practical example and in the report that will potentially come for this program, Bethlehem knows everything about the program. So all the questions related to the program, please direct them to her. Good. Right, so just to give a brief outline, we'll talk briefly about the project description, move into the design of the project so that you have a bit of a context, unless someone from Ethiopia is already here. And then we talk about just the basic concepts of how we went through about the data collection, then talk about the descriptive statistics, which we talked about yesterday, and then move on to regression analysis. So what we've been doing all the way since yesterday, we'll just summarize it into one evaluation from Ethiopia under the Eutf, right? So again, feel free to break me at any point in time in order to ask your questions, right? Well, not during a sentence, but maybe wait for me to end a sentence and then ask your questions. Raise your hand, like a question, etc. Right, so briefly to describe the project, this is, a very simplified description. It's a much more complex project, but the name of the project is C4ed. which is to strengthen socioeconomic development and better employment opportunities for refugees and host communities in this zone in Somali region in Ethiopia. So the great idea or greatness of this title is that you basically get the overall idea of the program through here. You know where it is taking place, you know who it's targeting, and you know what the effective goals of the project are, which is exactly also implied in this overarching goal, which is the improvement of or the enhancement of the economic inclusion of these refugees in the Somali region, mostly by expanding their access to financial resources. And now this is not only targeted refugees, but also the host communities where these refugees are currently based. The aim, of course, is, as most programs, is not just to reach the 17 individuals we were talking about in our regression, but actually 54,000 individuals from refugee and host communities. It started in May 2019 and was expected to last 44 months. So I believe it has concluded in January of this year. Right. So how does this financial inclusion take place? Is basically through the VSLAs, or the Village Saving and Loan Associations, that were specifically focusing on youth and women, right? So again, you remember when we were talking about targeting in the first place, when talking about CIE in the first recap session, you know, you can have certain target beneficiaries. And in this case, it was women and youth. And the aim was to establish 318 VSLAs and acquire a basically group of 20 individuals to be part of this VSLA, implying about 7,620 beneficiaries. Again, there is a much larger other component to this program, and I'm only focusing on the explaining the impact or the role of VSLAs in the program. The rationale here still being that if you improve the access to savings and loan services for refugees and host communities, you end up improving their economic well-being and empower them economically. So what exactly was the design in our case? And by design, we're always talking about CIE, or counterfactual impact evaluation. So the question that we were interested in answering is, or one of the research questions of our program is, to what extent the C4ed program changed the resilience and livelihood for beneficiaries, right? Now, very big terms such as resilience, livelihoods, let's just simply summarize it as income, right? So what was the change in income due to the program for the beneficiaries? And through this, the treatment or the particular part of the program we're interested in is simply the formation of VSLAs. This was covered largely in the years 2 and 1, and we went with, for our CIE, a cluster design. And the cluster here is always a group of units. In this particular case, communities. And what we were doing is assigning treatment not to individuals, which was what I showed you, you know, when we were doing the random lottery design, it was always individuals. In this particular case, we were talking about communities. So one community is given the treatment and another community is not given the treatment, which is the program. And now our aim for the evaluation is to measure the exact or quantify the impact of these VSLAs, the program, the treatment, on our employment outcomes and income. Again, this is how we are approximating resilience and livelihood improvement, right? So how do we measure impact? For starters, we need to compare, remember, coming back to our counterfactual idea, we need to compare clusters that did receive the support in the form of VSLAs to clusters that did not. And clusters in this case is communities. So our cluster design relies on some communities that received the program and some who did not. The challenge is, how do we attribute the differences in the program and select, in order to attribute the differences in outcomes due to the program, we need to be able to select our treatment and comparison communities, right? And ideally, we would have liked to have a RCT design, and to not be unfair to any community, we would have liked to simply say, okay, you randomly we're selecting some communities, you will receive the program and you will not receive any support from the BSLAs, right? So this would have been the fair solution. However, real life is not fair. There are operational constraints. Some of these randomly selected communities are simply do not have the infrastructure. Sometimes you simply do not have the communities are too differentiated in considering it fair not to give them the program in the first place. So these feasibility or operational constraints also existed in this case. And as a result, what we ended up having to do was give the program or the treatment to particular communities and then treat the remainder as non-program or comparison clusters. So this was not a random allocation. But if you remember in the recap session, we don't just have randomization as the CIE method, we also have other opportunities, and that therefore our plan B was to move towards a quasi-experimental approach. To be very specific, we went towards matching. And matching, if you remember, was simply from our sample, taking those individuals who are most comparable and compare these individuals as the counterfactual and the treated group and get your impact of the program. So we have our two samples now, and we were trying to establish through a regression analysis what the impact is of the program. Knowing that we are unable to control for some of these or because we are unable to randomize, some of these confounding factors or confounding variables needed to be included into our setup, which is why our regression analysis was using these confounding variables and thereby ensuring that we are able to control for all differences that we are not able to control through the CIE method itself. Right. So let's talk about the data very quickly. We have host communities because it's targeting host and refugee communities. These are 70 clusters through which we were targeting 1,050 households in our sample. In the refugee clusters, we had refugee camps. We had 6 clusters through which we were targeting 720 households. Within each type of clusters, the division was pretty equal. So the split between control and treated clusters was pretty equal. And so in total, we have 76 clusters where 38 were treated and 38 were controlled, right? And what we then went about doing was creating our tools to collect data. And this is now the quantitative element that we're focusing on, not the qualitative. And the idea was that we focus on getting information not only for variables that we're interested in, so resilience and employment or resilience and livelihood as defined by employment and income improvements, but also understand what other potential confounding factors might affect our relationship between receiving the program and employment and income. And this is why we collected information on gender, age, education, household size, assets, etc. Right. What we find in the end is, what we now start reporting is using our data first, our descriptive statistics, right? What I showed in session 1 was the simple difference in means. We showed a table where you were able to see, or we were able to tabulate for each gender what is the difference in income, or for the different levels of primary education, or different whether or not you have primary education or not, what was the difference in income, right? So these kind of tables we were looking at. In the report that you might get as well, you will see something called balance tables. So let me briefly explain what these balance tables are with just 2 of these variables. So we took data for the entire sample, but you remember we have a treated sample and a control sample. Treatment is those who receive the program, control are those who have not received the program. So what we will try to do is for this entire sample, but also for the treated subsample and our control subsample, we derive the mean value for age, which tells us the full sample is about, on average, 36.7 years old. The treated is 36.5 and the control is 36.9. Right underneath this, we also see the standard deviation. So if you remember, the standard deviation was simply on average how different each observation is, or how far each observation is to the mean. So the difference between the mean and each observation on average. And this is the standard deviation that is reported here to give you an idea again of the dispersion in your data. Thankfully, at least the standard deviation is not, if you remember our example of income, where 885 was the mean and 1,800, so nearly double or more than double, was the standard deviation. Here, at least, it's a third, which means that our data is not extremely dispersed. And then the same thing is done for the female or the gender of the respondent, which means we see that 72% of the sample. So you again see a decimal here because in reports you generally show proportions. Proportions are always between 0 and 1, and to get an idea of what it means in percentage, you simply have to multiply it by 100. So you see 72% of our respondents were female, whereas 74% of that was from the treated group and 70% of that was from the control group. So in each group, the proportion is different. So the last column that you see here is simply the difference in means in the first place. So you see here, it's subtracting 3, the value in 3, from the value in 2. This is what it says over here. And underneath it, it gives you the p-value. So this is not the standard deviation, but the p-value for this. So the fourth column is giving you the difference between the two groups that you have in your data set. Here, what is the p-value? It's 0.48 multiplied by 100, it's 48. What does that mean? For any kind of significance level, we cannot reject up to 90%. So we can, of course, reject our null hypothesis with 50% confidence, but that's not what we are going for. We are going for something that's closer to 90%. And so we cannot reject the hypothesis, null hypothesis, which is to say that the two groups are similar, right? So our null hypothesis is there a difference in age between the two groups? There is none. And we cannot reject the null hypothesis. The second column, however, is the difference between the ages or the share of female respondents in treated and control group, right? Our null hypothesis is that the female respondent between the treated is, or the percentage of female respondents in the treated group is same as, sorry, let me reformulate the null hypothesis. The difference in percentage between the treated group female respondent and the treated group and the control group female respondent is 0. This null hypothesis, however, we have to reject. If you see the p-value here, it's you can clearly see it's 0.07, so 7. So at the 90% confidence level, we can comfortably reject this null hypothesis, which means that this difference of 4% or difference in proportions of 0.04 is valid, and our treated group has more female respondents than our control group. And this is how sort of you read a balance table such as this. I've basically tried my best to do this. Again, remember, these are simply the means. This is not a regression analysis so far. This is just calculating the averages from our data through the simple tabulation and means that we did in this session 2. Then through session 3, the results of the session 3, we are able to calculate a t-test for these values and acquire a p-value such that we can reject or accept our null hypothesis as to whether there are differences between these two samples. There is no difference in the terms of age, but there is a difference in terms of the share of female respondents. Through this balance tables, what we attempt to do is simply at a glance try to understand whether our treated group and our control group is different. So we are checking the balance, if they are balanced or the two groups are balanced overall. What you see here is all of, well, more or less all of the results. The total sample is 1,936, of which 1,129 belong to those groups that was treated or received the VSLA program, and 692 were those that were part of the control group or did not receive the program. What this last column should show you is the imbalance, right? In the previous case, I showed you a 90% confidence interval, which was represented by this tiny star here. As your confidence increases, you keep increasing the number of stars. And this note at the bottom always signifies what the confidence level is for each variable here in this case, or each observation, or not observation, sorry, characteristic here. So if you're at the 5% significance level or the 95% confidence level, then you represent it with 2 stars. And if you're at the 99% confidence level or 1% significance level, you reject your null hypothesis and show it by 3 asterisks on the top. What you see is there are imbalances between the group when you compare them at baseline. Please remember, for matching, you always compare the groups before the start of the program, that is at baseline. So already at baseline, we see that there are many things that do not match in our group, right? And therefore, we need to apply matching to this method, or we need to control for these aspects when we run our analysis in the end. So let's look at the same variables, or let's look at the outcome variables now at end line. So we were checking whether they have a stable job, if they're self-employed, if they're interested in starting their own business, if they invested in their own business, what is the average income over the last 6 months, and then the annualized monthly employment income. These are now the averages. So again, still just the means of each of the groups. The full sample, just the groups that received the program, and just the group that did not receive the program. If you look at this column simply, it will tell you the difference. So over here, you see that the treated group is more likely to have a stable job. And in fact, the quantification of this is 12% more likely, right? 12 percentage points more likely, which means to say the difference between the two groups is 12 points. And here, this difference, so the treated group is 12% more likely to have, percentage points more likely to have a stable job. And that is a result that we can conclude with 99% confidence, as you see with these 3 stars. And other results, again, you can look at them through this slide. So what we find is overall, there are more the group that received the program has a stable job, is more likely to be self-employed in a stable job, is, however, less likely to start their own business, as you can see with this negative sign, is more likely to be interested in investing in their business. There is no impact, however, on income. You see no stars here. You see a very large p-value here, so 60, 65 or 53, whatever, 0.65 or 0.53 as the p-value. And therefore, we are not able to say with any confidence that there is a difference between our treated and control groups. Again, all just through the result of a t-test. So very quickly, I know we're over time now, but I'll try to explain what the results for the regression analysis was. Again, we are trying to establish a causal relationship between our outcome of interest, which is, let's say, our employment or income, and the treatment itself. So the treatment here is the program and what the impact is on the outcome. And we are interested in this B value, or the relationship or the quantified relationship between the program, having received the program, and the outcome. We also include other confounders, and therefore this is what our regression setup looks like. Let's ignore this error term for now. Okay, so our first option in this case would be to run a simple multivariate regression that we talked about previously, including all confounding factors. A more robust setting in this would be to account for the clustering, because we were not randomizing, or we were not giving the treatment of the program at the individual level, but at a cluster level of communities. You need to account for the change in your error, this term again, that happens as a result of the clustering of your program. And this affects your statistical results, and that's why you will find that often in reports, people are also reporting clustered standard errors related to the cluster where the program is given. And then finally, you have the third option, which is just the complex approach of mixing regression analysis with matching. Now, remember, this was the approach where we said we tried to control for these initial differences by matching the most similar individuals. And this is the actual quasi-experimental method that we used in our evaluation as well. So what does our regression look like? Now here, we've moved away from a difference in means, and we are actually showing you regression results. Having received the program, it means that you are, again, this is a proportion, so multiply this by 100, 11.9% more likely to have a stable job. If we were to cluster our standard errors associated with the program clustering, we get a similar result, and that is at 11.8, so still around 12% more likely to have a stable job. We are also about 6% more likely to be self-employed in a stable job, 4% less likely to be interested in starting our own business, and so on. What you would see between these two is that there is a difference sometimes in the coefficient, but also the changing in the standard errors here. Here there's a change in the standard errors. Here there's a change in your standard errors, which is generally what is reported underneath your B. Your B is often reported with your standard errors, which is, again, if you remember, a measure of dispersion or variance in your data. And this, for example, has changed between these two. And as a result, how it affects is your your confidence level is changed. If you remember, again, your confidence intervals, it is derived with the help of if you remember that formula, it was Z times standard error. Because your standard error is increased, your confidence levels have increased as well. And therefore, you can say your bandwidth has increased and you are less confident about your results indeed. Okay, and then finally, we show you the results of option 3, which is having used a counterfactual impact evaluation method, which is matching, to control for the selection and not being able to control for these observable differences in our data. I will not go into the intuition of matching, simply go into the results of the regression. And what you see here is the third column, which is showing you the regression, but accounting for the CIE method or used within a CIE method. And this is basically your overall result. Here, again, similarly, but now the coefficient B is higher. That is to say that you are 12.3% more likely to have a stable job. Again, statistically significant with 3 stars, so with 99% confidence or at the 1% significance level. Our self-employment status is also similar. What you observe here is that your interest in starting your own business is actually a smaller coefficient, but still statistically significant now at the 95% confidence level or the 5% significance level. And so on and so forth. You can look at all of your coefficients. Sadly, what we see is that there is still no impact on income. Again, maybe income is something that moves a little slowly, whereas employment status can change quickly. Right, so to conclude, it was very quick, but it's trying to give you an intuition, but also a preview into what your results and your evaluations can look like if you use regression. Again, it's a powerful, flexible tool, but only one of those tools that is available for your analysis, especially when you combine it with careful design, careful sampling, so that you reduce your sampling errors and are able to employ a good CIE method along with it. And with that, I would like to end session 2 with only 2 minutes before actually session 5A starts. Are there any questions to this? Then I would like to hand over to my colleague Innocent, who will briefly introduce himself and then talk about qualitative methods in your evaluations as well as triangulation within it. Thank you, and handing over to Innocent.
Thank you very much, Atika. Okay, could you quickly confirm that you see my slides on the screen?
Yes, Innocent, we can see the slides. Thank you.
Okay, perfect. Okay, perfect. Thank you very much, Caroline, and thank you, everyone. Good afternoon, and welcome to this session on qualitative analysis and triangulation for counterfactual impact evaluation. And yeah, I will be using CIE for counterfactual impact evaluation. From now on, my name is Innocent, as has been already mentioned, and I work at C4ed as a qualitative research and evaluation manager. I have a background in qualitative research with a PhD in anthropology. So basically what I've been doing in most of my work is applying different qualitative methods, approaches to collect and analyze data. So among the projects that I'm working on here at C4ed is the Eutf portfolio evaluation. And because of this project, I might have already met some of you or maybe had interactions with some of you on different occasions. And yeah, so most of the Eutf evaluations that C4ed is doing is applying a mixed methods approach. So this basically means combining quantitative and qualitative approaches in the whole evaluation. And in the past couple of hours and also yesterday, you've heard a lot about quantitative analysis. And in this session, I want to introduce a little bit some of the elements of qualitative analysis. And for this session, it's going to be quite theoretical, but luckily, the session that we have after lunch is more is sharing a case study. So I would try to relate the theoretical elements that I'm going to discuss in this session more so that it's a little bit understandable for everyone. And of course, I'm happy also to have discussions. If you have any questions during the presentation, I'm happy also to hear your views and share your experiences. Okay, so maybe just to give you an outline of how we're going to proceed. How I've planned this is we have an overview of qualitative research and its uses. I think in the last couple of trainings in the first year and the second year, there was an emphasis on the quantitative side. So I would like to a little bit delve into the qualitative research as an introduction, showing you the basic approaches also for collecting qualitative data, and then dive into the methods and tools for data analysis, for qualitative data analysis, and how qualitative data can be used to answer certain questions that quantitative may not be able to, or might be too expensive to apply quantitative methods. And then finally, I would also like to look at how qualitative data and quantitative data can be triangulated to validate findings. So this is how I have arranged it. In the session afterwards, like I mentioned, the case study will try to draw again much closer on the analysis and show you how we have done analysis in a mixed methods project with several evaluation questions, so that you can get a little bit a clear idea of how this is done. Okay, maybe As an introduction, I'm not sure to what extent each of you has been exposed to qualitative approaches or qualitative data collection. But I know from also just having conversations with others, but also some have written about this, for example, the famous author Bemberg, how people view qualitative data sometimes. Sometimes it's categorized as simple anecdotes. Sometimes it's looked at as any small meeting or conversation is considered an in-depth qualitative data or qualitative interview. And also sometimes there's the perception that, oh yeah, this is quite simple and cheap and fast. But just to go a little bit beyond that, I want to just emphasize, and also as part of qualitative research, to show that it's a systematic research approach. And it focuses on various things, which I'll go through briefly or shortly. But generally, what qualitative data is trying to do is it's trying to understand and interpret complex and nuanced aspects of human experiences and behavior and phenomena. So it involves gathering data, but that is numerical. So we might not talk about percentages, like it might be done in the quantitative data, but we'll look at, let's say, different narratives, which are textual, some are visual, and some are audio information that then we analyze. But in short, this is basically to uncover some underlying meanings and patterns and contextual insights that might not be easily discovered using numbers and figures. Okay, maybe just to dive rather into the topic of using qualitative research in evaluation in the CIE. So why do we do this? So we do this, one is to understand the views and experiences and motivations of beneficiaries, implementers, and different stakeholders in a greater depth. So it's similar to what I just mentioned. And also to understand the process, the mechanisms by which certain impacts have occurred. So in many cases, we always ask the questions, how has this been done, and why has this been done? So for instance, why has a certain impact been arrived at, or why not? So if there was a goal to make some changes and some things were not done, so we asked the questions, why not? And if it was achieved, how was this achieved? And also in many cases, as we do our qualitative investigations, we come a lot into unintended consequences or outcomes, and these sometimes are positives, these sometimes are negative. And then, of course, we want to answer questions about meanings, motivations, and examine how particular behavior and action have been understood and how people make sense of their circumstances. So this is what, when you think about what you've learned already yesterday and today morning as CIE, and maybe you had some questions about maybe some missing elements. How can you arrive at certain impact? So this is how, in many cases in a CIE, how qualitative research comes in to fill in certain gaps or to complement what the quantitative side has achieved. And furthermore, we try to address evaluation questions that are not tackled by quantitative research methods. And this I will demonstrate a little bit better in the case study that we'll have, because in some cases you have certain questions that are well addressed using quantitative methods, and some are well addressed using qualitative methods, and sometimes you can use both to address the same questions. And there might be various reasons for that. It could be the timing, it could be the cost. But yeah, I hope I can bring this a bit closer when we go into the case study. And then also, yeah, to complement quantitative research by providing additional information, and also reach some respondents that are hard to reach, for instance. So this has been also applied in different places, and also it's because of the method, the different methods that we apply, that sometimes it's easier using qualitative methods to reach certain respondents compared to applying quantitative surveys. And then also we analyze underlying socio-cultural, political, and economic aspects as a summary on that. Before we go into the methods that I wanted to show you that we use for data collection, I wanted to briefly also discuss the timing. So if you think about a counterfactual impact evaluation, you have a strong quantitative approach that has been put there, that has been designed, and sometimes you ask yourself, so at what time should the qualitative approaches come in? So there are mainly three phases where the qualitative approach can come in when we're doing the CIEs. One can be before the quantitative data collection starts, or the quantitative design is finalized. An example is the evaluation that we are doing in Ethiopia with Mexico. I'm not sure if there are some of the participants here are part of that project, but what we did was that there were certain contexts that wanted to find out before implementing the quantitative data collection. So the two groups sat together and tried to find out the different contexts, what was needed, and the qualitative team went into this area and carried out some key informant interviews, and we use this information to inform the quantitative design of the tool, and then after that we can go into the field and collect the data. The second way is to apply these in a complementary, or rather in a parallel timing. So most of the Eutf projects that we are evaluating at the moment, we are applying both quantitative and qualitative data collection at the same time. And this again, so when we go further into the presentation, I will talk about triangulation, and one of the reasons why we're doing this is to be able to triangulate the findings.
Innocent, sorry for interrupt you, but
yes.
I have a question here, and I would kindly ask, yeah, to come in.
Yes, please.
Bonnie or Tu, do you have a question?
Yes, not a question per se, but I wanted you to go to the previous slide, Innocent.
Yeah.
I wanted to understand what you meant by outreach per se, that cannot be reached through the quantitative method of data collection, but through the qualitative. Would you please qualify what you meant by outreach respondents that cannot be reached under quantitative, but reach under what? Under qualitative. Yes, and
Yes.
I understand that hard to reach what you meant by it. Thank you. But so far, so good.
Yeah, thank you. That's a very good question. Let me use rather an example. So in one of the data collections we had in Nigeria, it was related to health. And we wanted, it was basically carrying out surveys of different people who had benefited from, who had been targeted by a certain project. In the process, in the sampling process, there were many people that could be reached, but there were different people who had moved to different parts of the country. And there are certain parts of the country that could not be accessible because of the conflict of the Boko Haram. So they could not be interviewed as parts of the households of this survey, and also with the timing, trying to find them was just taking too much. So the qualitative component came in here, and we designed an approach. One was to try to find people who had been part of the project implementation, but were in areas where these people had moved to. So we personally couldn't also reach them, but we designed then different questions that could explore the different reasons why or how that benefited from within these projects. So, and then these people within this area, so the people that we could access who were part of the project could then on the ground over several weeks try to find these individuals and issue out these questions to them without risking, of course, their security, and so this is how we could indeed, in the end, reach out to them, collect this data without having them to be part of the survey. So this is an example of what I mean by hard to reach respondents, and this could be different situations. Generally, sometimes hard to reach respondents could be related to a topic. So if a topic is quite sensitive, then you cannot easily go and issue out a questionnaire. You have to kind of go through certain processes, build certain level of rapport, or use certain networks, and these are usually also qualitative approaches that we use. So I'm not sure if that answers the hard to reach respondent group for you.
Okay. Yeah, partly.
Okay.
Partly, because I would also think you would also collect data, quantitative data, even if somebody is hard to reach. Because I mean, why do we choose that we're using if it's hard to reach, like you said, in Boko Haram area, and we are okay, maybe it's qualitative, which is the best to collect the data through qualitative means. I don't think that would be the criteria to select whether we should employ a qualitative data or maybe a quantitative data collection method, because that area is hard to reach. But it's fine, and I see where you're coming from. You see, maybe that would also maybe a discussion. We'll say, okay, if you're determining which kind of data collection method to employ, what is it that should this one to be a quantitative data, or this one should be a qualitative data collection method? Because I would presume if it's hard to reach, you may not, like this in this case is a Boko Haram, and you're collecting a qualitative data, you're not going to use the focus group discussion to collect specific data, but rather you can maybe use the key informant interview, maybe through the phone call remotely, and collect that specific data. The same thing also you can actually also use even the quantitative data to collect that data collection. That is it, but I get it. Thank you.
Yes, thanks. No, that is really a good observation on. I think once we're doing a design, there are certain things, like I mentioned, that you try to figure out within that specific context of the evaluation. So you ask yourselves what would be the most cost efficient and the most cost efficient way of collecting this data, which is still rich, and we can use for our analysis. Of course, in many cases, you can still use either approach, but then sometimes you weigh what is the cost advantage in that. And so in this case, maybe the example was a bit too generalistic, but for this particular project, and the context until we came to that conclusion that we apply the qualitative approach, was more that, okay, yeah, there was a timing issue. There was a certain level of data that had been collected for the quantitative. And so how could we then make this whole data wholesome? But indeed, there are different criteria that when we sit down at design level and planning, we see, okay, so what's the best way that we can get this data that is still very rich and can help us in our analysis without, let's say, risking people without doing so much damage, and without it being extremely expensive. So there are so many. So, but thanks a lot for that observation. Okay, so here I'd explained why sometimes we go before the quantitative group in the field, and also why sometimes we go in parallel and sometimes we go afterwards. And so this is more to then provide more explanation to the data that has been collected already from the quantitative side. And here within the Eutf data collection, we don't have a concrete example on that, but the Eutf Uganda, which will also be the example that I will share later in the case study, there were different phases when the quantitative group went to do the interviews, their surveys, and there was a different time when the qualitative went, and the qualitative went in the field when there were already some results that we knew from the quantitative side that needed a little bit more explanation. So these are the different timings that you can say, okay, in this CAE, let us roll out the data collection. Okay, now I wanted to just introduce briefly the main methods that we use in qualitative interview and in qualitative data collection. So these are mainly three. We carry out interviews, we carry out focus group discussions, and we carry out observations. So I will just explain a little bit more on this. So when we think about key informant interviews, what comes in mind immediately? So this basically involves interviewing people who are who have particularly informed perspectives on an aspect of the program being evaluated. So here the interviewers try to frame the interviews or the questions as open-ended questions, and also probing questions and probing to get some more external information. They take notes which are later elaborated. And so why do we use this? Why do we interview why do we use KIIs? Here, so for instance, when it's important to gain an understanding of the perspectives and motivation of stakeholders and partners regarding an activity or project, in order to explain the implementation process, shortcomings, successes of the intervention, the different challenges, sometimes also at a greater level, the different contexts. It's very helpful to use the key informant interviews. And also when we want to generate recommendations. So sometimes when you're thinking about recommendations, you want to get different perspectives. So from maybe implementing partners, but also from the people who have been participating in the project as different stakeholders. So this would be very helpful to do that. And then we have in-depth interviews here. Again, in-depth interviews involve interviewing mostly the beneficiaries of the intervention or a study with specific relevant profiles. So let's say we have farmers or child laborers or different community leaders on the ground. So it would design some sort of in-depth questionnaire that can elicit certain in-depth information that we want to get from them. So some of this is to understand their personal experiences on the topic at hand. So this would give you, as an interviewer, more of a feel of the certain outcomes or certain impacts, to understand what has worked and what has not worked, and why. So as I explained at the beginning, we usually ask the questions of how and why, and then to generate recommendations on different lessons learned. And then the focus group discussions here, it's used as a group interview designed to explore people's attitudes. So when we want to find out issues that concern, let's say, the community or the group, and there's little information available, we tend to apply focus group discussions. They help in adding meaning to the information that you already have, but also implore still the questions of why and how, and also to understand a collective or a public attitude around a certain topic. And usually what we do is that how we do this, that we have this structured guide with certain topics that we want to discuss with the group, and we usually have 2 facilitators, and we try to make sure that the characteristics of the group members is similar, related to the topic that we want to discuss. For instance, if we want to discuss women empowerment, we might have a focus group discussion with women. And usually the number is between 6 and 10, because that is a recommended number that is manageable, where you can still have a good discussion without going over time, and everyone has a chance to to say what's on their mind. So that is briefly about the different tools, and also the qualitative approaches. I'm not sure if you have any questions so far that we should respond to at the moment before I go into the analysis.
Yeah, Innocent.
Yes, please.
This is Bon again.
Okay, hi.
On the methods that you highlighted,
Yeah.
if you talked about interviews, which I think is key informant interview, and the IDI.
Yes.
What could be the difference between the key informant interview and the IDIs?
Yes, please. Yes, that's a very good question, and in many cases, people also struggle with that. But I would, what we are doing here at C4ed is we then look at how the World Bank also approaches this. So when we talk about key informant interviews, for the sake of categorizing, we look at mostly people in positions of implementation. So if a project, let's say if GIZ is implementing a project in Uganda, and there are officials within GIZ, maybe the project officer, the M&E, the head would take that, would design questions related to implementation, and these would be key informant interviews. Also, government actors who are involved in this project would consider them key informants. If we go, if then we want to talk more on the people who are on the ground, who have not just the general knowledge on the framework, but rather more of tangible feel of the project. People who have been, let's say, on the ground, let us say a village chief, or it could be a district, or a district office, a district officer would define our questions, or rather our tool to go rather in depth within this particular project implementation. So how, for example, the day-to-day implementation has been carried out, what they've observed as some of the outcomes and some of the challenges, and indeed in different cases they have more to talk on such topics compared to the government officer who is based at the capital. So that's how we try to differentiate these two. And also then the questions are also different. So the key informant questions, we usually keep them at a framework level or at a regional global level, and the in-depth interview questions, we rather keep them more on the ground level. I'm not sure if that is clear, Bonnie.
It's clear though, because I wonder what data we collect always when they say we are going for key informal interview.
Yes.
And we're interviewing maybe other partners also of the project. We are interviewing maybe also, like you said, maybe GIZ, you get it, those top officials. And we said that we are using key informal interview, but what I'm saying, it could actually be an in-depth interview. So I don't know if I would be right if I say that if we're interviewing at the primary stakeholders of the project, let's say maybe the beneficiaries and maybe the donor, we will go for an in-depth interview as a tool. Then maybe the external, maybe of the work project, maybe the media, maybe the local authority, like you said, the government officials, maybe the OPM. That would be kind of the key informal interview, because you're not only going to ask questions about the specific project, but also maybe you'd expand maybe their general perceptions about maybe a sector. Thank you.
Yeah, no, and that is one of the debates that still go on in the literature of what is a key informant interview and what is an in-depth interview, and that is totally valid. And you'll also realize that, or maybe we have realized that in many cases, in different projects, there's a different level of involvement of the implementing partner, the IP who is implementing the project, and they also have a certain, let's say, perception that they have regarding this project. So let's say they look at the challenges of the implementation differently. They might have a more global framework or design of this project, so they understand it in a different way compared to, let's say, a village chief in whose area this project is being implemented. So rather the form of questions that we would design, and also this is more also for the efficiency of the data collection. So the form of questions that we would design at this stage for the key informant interviews would be, let's say, looking at a relevance question. So if we look at the DAC criteria, we look at there might be a field more with the relevance questions. It might be filled with the coherence questions. It might be filled with the sustainability questions, and again. And I'm not saying that these questions should be limited to them, but there's that tendency that these a group of people would be best suited to answer such questions. And then there are the different other questions on impacts might rather be going to the beneficiaries and also the local chief, with seeing what kind of changes have been there in the last, let's say, 5 years or so. This is indeed how we try to rationalize it out. But when we talk about the theoretical basis of what a key informant interview is, or an in-depth interview is, then indeed there's always these cross-cutting issues. Where does the boundary start and where does the boundary end? And the debate still continues, but I'm glad that you brought it up.
I understand we have another question.
Yes.
On hand raised, so please come in, Andrew.
Yes. Thank you so much, Innocent, for that presentation, and also from the side of Bonnie, that elaborate approach. So I wanted Innocent to guide me on one thing. Normally, when we are developing the key informant interview guide for any evaluation or assessment, we normally make it as brief as possible, because the respondents which we target during the key informant interviews are always busy people who don't give us enough time for us to conclusively assess them about the subject matter. But normally what we do during the in-depth interview is that we don't segregate between which respondent we are targeting. So any respondent who can give us reliable information about our assessment is the one we go for. But we target that specific respondent who is knowledgeable about the subject. So he or she can be among the key informants or our primary beneficiaries. But the way we designed the in-depth interview guide is that we collect in-depth information about that the subject matter. So this is normally detailed, and we normally take much more time analyzing the subject. So please guide me if I've been doing it right or wrong. Thank you.
Andrew, you've been doing it absolutely right. So, so the key informants, like you've rightly said, usually they give 45 minutes to 1 hour, because indeed they are busy. And me as an interviewer, if I want to really get in-depth information on a certain project, and I know that it takes about 1.5 hours, I will not try to make an in-depth interview with someone I consider a key informant. So here again, and again, in general, as if someone is to categorize or to make a boundary, then you might realize that, okay, if someone is, let's say, a minister of education, or a permanent secretary, or a donor or the head of a program, a country head of a program, they might have only 45 minutes to give you. And so you kind of also frame your questions and like I mentioned, like what is common, and this is not also exclusive. If you have certain coherence questions, relevance questions, value addition questions, you kind of like frame them for this group of people. Then if someone has been more on the ground, and you're right, Andrew, that sometimes the people that might be categorized as key informants, let's say a project officer working for an IP, might have certain in-depth information about that project and also has time. So in this case, it's also common that then you design, instead of issuing the key informant interview question guide, you rather design for that person the IDI guide, and then try to delve into the different nitty-gritties of that project. So that's also true. And again, and indeed, like the debate also still goes on, this clear-cut definition of what an IDI and the KII is a little bit different, and also depends on different projects. For some projects, it's totally different. You might find that the maybe the organization that is implementing it is rather a smaller one. So the person who is the head of, let's say, the country head of that project is actually covers only a certain village. So then it might make sense to have an IDI with that person because they're there on the ground instead of having a KII. So just in short, you've been doing it right. So you look at the tool and you look at the person's experience and what kind of information you want to get out of that person, and that helps you to either decide to issue the KII tool or the IDI tool. And the KII tool is usually shorter, broader, while the IDI tool is usually longer and more in-depth. Okay, I see that, yeah, we still have maybe about 25 minutes, and I would like to use this to go through the second half of the presentation. And if we have time, we can discuss a little bit more, but I also believe that the case study will, again, will have more discussions once we go through the case study. Okay, one question that usually comes is, once you have your qualitative data, what do you do with it? So if we had time, I would have started by asking you, because now I realize that a couple of you have done, have collected qualitative data already before. Yeah, so the first question is, yeah, so what do we do with it? And as I introduced before, is that these are usually different levels of narratives. They can also be visuals, they can be videos, they can also be observation notes that you might have taken while collecting the data. And so what we usually do is to try to make sense of all these narratives and visuals and videos. And a helpful way to do this is to try to code them. So to organize them in such a way that you can understand them, someone else can also understand them. This process is iterative, so it's not a single process. It can go on and on, depending on how much time you have and depending on how complex the topic of analysis is. And in the past, so you see that computer, people had all these different small pieces of paper which have different meanings. So yellow might mean something else, and blue and purple, etc. And this is also a bit tiresome and exhausting. What we do here at C4ed is that we have certain qualitative analysis software programs that help us to do a similar thing, but in a way that we can still access them and also share this information. So we use MaxQDA as a software. I'll show you in the next slide how it's displayed. And so what we do is that we do a series of different types of coding. So we do like open coding, where we identify and label the meaningful segments, which we call codes in this case, within the data, and these codes represents concepts, themes, and patterns in the text. And then when we have this open coding, we try to connect them and organize them and connect them. So through Axio coding into different categories and themes, which might be a bit larger. So we check out themes that are emerging, and so we kind of group them into these larger themes. So this helps us to make sense and understand the relationship between the different codes. And then once you have this, you again rethink, look at the different codes, you refine them, you focus your coding, and you see what kind of information that you're trying to get out. And this, like I mentioned, it's iterative. And one thing that doesn't come out here, which I've not mentioned, is that the whole process also falls back on the types of evaluation questions that you have. So when you're thinking about your coding and your coding tree, you think about your evaluation questions and what you wanted to get out of that. And then in the first step of open coding, you think through the different narratives related to these evaluation questions. So this is, I'm not sure how well it shows, but so the MaxQDA display, how it helps us is that it has these 4 windows, and the document system, that's the one on the upper left for me. That's where you put all the material that you have, so the interviews, and you can arrange them in different ways, the way you want to analyze them, or the way that can be easily accessible. And then below that, we would have the coding system. So here we think about our evaluation questions and what we wanted to get out of those questions, and already formulate some codes that are called the parent codes. And then and then when you start the process, when you open a document on the upper left, so from the coding system, the document browser opens that document, you read through, and then you mark like the different parts of the document, and these you mark them as the different code. So it could be a topic on gender. If it's something that's bringing out gender, you mark it as something on empowerment, something on resilience, on livelihoods, depending on whichever topic that you're addressing in your evaluation. And then down, you can always retrieve certain codes. So if you say you want to retrieve only information related to gender and nothing else, then you get only information related to gender, and then you go through that and try to understand what is coming out of your data. If it's on empowerment, yeah, you go through this. Of course, in your questions, you've been focusing also a lot on reasons, the different reasons why certain things have happened and why they have not happened. And if the reasons on gender come up, you find them all in one place and you can easily retrieve them. So this is how Max QDA helps us in the coding. Of course, there are also further ways of looking at this. So we, as we are doing the coding, we are doing also some sort of analysis, or at some point when you have all the retrieved codes, you do certain levels of different analysis. So you do the content analysis, and here it's trying to make everything systematic and identifying the categories and the different visuals. Maybe you're identifying keywords, like, again, I'm going to use the example of gender. It can be many other things depending on the evaluation itself, and then putting the codes together and trying to understand the content, what is coming out of that. And then when you arrange them as themes already, so you've collected different types of codes and put them together, you do a thematic analysis. So what is getting out? What kind of patterns are you seeing from these themes? And again, like I mentioned, this whole process is again iterative, and if it's not yet clear, you still go back to your codes, you go back to your transcripts, read them in order to make strong evidence for the themes. And grounded theory is not very common that we use this in impact evaluation, but it's more inductive, where you might not even have a certain focus at the beginning, and then you only depend on what is coming out of that, of the transcripts, of the codes, and it might not be exactly related to your evaluation questions. So maybe just to rush a little bit. So how can qualitative data complement quantitative? So again, here we will see in our case study more, and let's say there are various ways this can be, which cannot be exhaustively explained here in this presentation. But one thing that I've already mentioned is exploration. So I mentioned that the Eutf Ethiopia, we had a part where we did an exploration before, and that could help inform the quantitative tool, and this was very helpful. We can also use explanation to provide some explanation, like we used in Uganda, to provide some explanation of why attendance of VTIs was the way it was, why there were some dropouts. We can use it to understand different motivations, also help in generating hypotheses or research questions and subsequent quantitative data, identifying unanticipated factors. So in some cases, the unintended outcomes might not easily be part of the questionnaire. So, but in the narratives, you might eventually identify several unintended outcomes, which can be positive or negative. And then to triangulate quantitative and qualitative data. And this is also what I want to then focus on as a closing part of the presentation, just to explain a little bit more on the triangulation. So here you can just imagine you have a quantitative approach and a qualitative approach, and they are addressing certain questions, and you want to, let's say, increase your confidence in certain results or provide extra explanation. So you use the different data as a form of triangulation, and this can look in different ways. One of them can be as a form of convergence. So you are trying to look at what kind of agreements there are there between data that was collected independently from quantitative and qualitative, and if they are arriving at similar conclusions, and this increases, of course, the validity and the confidence. Yeah, and so this is a way of validating some of the results, and also providing certain maybe deeper insights of why certain variables can be correlated or not. Again, on complementarity is and most of the things, let's say right now, they're separated categories, but in practice they're very much intertwined. So with complementarity, the qualitative data again tries to explore a little bit more why and how, and we all know that in counterfactual evaluation, quantitative approaches are very good at finding impacts. And so sometimes in these cases, the qualitative data acts very well in trying to enrich the explanations of these impacts and provide a little bit more flesh to the numbers, if I may say. Again, here, when we are talking about expansion, is that there's some quantitative findings sometimes I will try to complement them or expand them by uncovering unexpected insights. So this is kind of repeating what I said about the unintended consequences, but this as a form, we look at it also as expansion. And then, yeah, again, when we're looking at convergence, what I already mentioned before, it's not just trying to find where you agree with the quantitative results. Sometimes you get results that are of the same evaluation question that are different, and this is good for reflecting on your methods again, and reflecting on maybe did something go wrong along the way in our design, or are there certain insights that we didn't think about before, and maybe recommend further exploration on those areas that were not, that are kind of like diverging, where there's no agreement. And then there's what we're calling the priority sequencing. And here, again, what we're trying to do is that sometimes, let's say, and this is a whole different topic on mixed methods, when you're combining the two different approaches, in many cases, one might be bigger or heavier, more emphasis. And it's rare that all of them have equal emphasis because of cost and time reasons. But anyways, what the priority sequencing is again doing here is that once one has certain findings, you want to explore them a little bit more and provide a little bit more more context. So you use the analysis takes like different levels. You first analyze one component before you go into the analysis of the next. So this is the last slide that I wanted to show you as an illustration of how we have designed like a bigger portfolio of the different evaluations. We see that the in-country projects, we have, it's a mix, they're mixed methods. We have quantitative and qualitative, and eventually for each project, they will come up with different interpretations and results. And for the what is called the R2 there, it has also different methods. Some of them are qualitative, some of them are quantitative, which will also come down again with different results. And in the end, we'll compare these results and try to provide an overall report on the learnings and generalizability. So that is basically it about qualitative approaches and analysis, and I'm happy to hear your comments. We don't have a lot of time, but I think we'll have more time also later in the discussions. Thank you. Okay, welcome back everyone from your lunch break. Caroline, could you quickly confirm that my screen is showing?
Yes, we can see your screen, and the recording has already started, so you can continue. Thank you, Innocent.
Okay, thank you very much, and welcome back to this session where we present a case study on mixed methods, and I think some of the topics that we discussed before will come up here. I'm going to present with my colleague Ellie, who is a quantitative research manager, and I think you've met him already before. And one thing that I want to say is that this session is only 20 minutes, so I would say it would be best if we keep the questions at the end, or if we write them in the chat and can reserve some 5 minutes to respond to them. And if you don't mind, if you could just mute yourselves, that would be great. Thank you. All right. Okay. So how we are going to proceed again here is that I want to give you a small background on the RISE project, on the RISE program, then the impact evaluation design that is showing the mixed methods approach, and then dwell a little bit on the mixed methods analysis, since this training is on analysis. And within the mixed methods analysis, we want to show you some examples on how there was complementarity and triangulation. So we cannot show everything that we discussed before, but this will just be part of it. So for the introduction, I would invite Ellie to give the introduction of the RISE project. Ellie.
Thank you very much, Innocent. Good afternoon and good morning to all of you. So I will just give a very brief introduction of the RISE program. I believe there might be one or two of you who were actually part of this, the implementation of this program. And the main partners involved were GIZ Uganda and then also the Norwegian Refugee Council. And this was an RCT, and I think we spoke about randomized control trials yesterday, and this is an example of a counterfactual impact evaluation that uses that methodology. This was done between 2021 and 2024. It's still ongoing. We're still collecting data to conduct the analysis and to estimate the impacts. So it was done mainly in Adjumani, Arua, Madiokolo, Obongi and Moyo in the northern part of Uganda. And the RISE program in itself focuses on, three main components, which is to strengthen local authorities to ability to deliver public services, and then also improving employment opportunities amongst young people, mainly non-agricultural income generating activities. And this is where most of the impact evaluation is actually focused on. Next slide, please. And as I mentioned, it was focused on employment, but mainly we were interested in employment opportunities for young people in host and refugee communities within the districts that we mentioned. And the objectives of the project was to train about 2,000 youth with the aspiration or with the hope that out of the 2,000 would have 70% of the trainees being female and 50% refugees. And this was done in 3 cohorts. It was done in 3 cohorts, and there were 2 main components of the training, which was technical short-term skills training, and then also in addition to that was an intense and financial literacy and skills training, which was done in addition to the technical skills training for 2 weeks. And so this was a particularly selected group out of those who participated in the main training, just to give them some extra training in financial literacy skills. So with that being a very brief overview of what the project was about, as I mentioned, the impact evaluation methodology itself was a randomized control trial, or is a randomized control trial. And just to give you an idea of how we went about it, we started with first receiving application of forms. And one thing that we stressed on was oversubscription. And as we talked about yesterday, if you remember, the bigger your sample, the more likely that your statistical precision will be high. And so we tried to overestimate or try to get more applications from applicants. And once we got these applications, what we did was that we randomly selected those who will be part of the training and those who will not be part of the training, right? Now the idea was that
we get back to them.
Sorry, could you please mute yourself, please? So the idea was that we would have a group that's very similar to each other before we split them into treatment and control. The treatment being those who will receive the trainings. And so for those who were planned to receive the trainings, we also split them into 2. One of them being those who would receive only the TSTT training, which is the technical skills training, and then those who receive the technical skills training, and then the intense financial literacy skills. And the idea is that at midline, and this was last year, what we did was we collected data from both the control group, that is those who did not follow the program, and then those who were selected and followed the program. So what we did was that we still followed people who were selected for the program but did not even attend, because we still wanted to have an idea of why they did not attend. And then we also followed people who were not selected at all. And the idea is also that I would ask or would follow these people again for the endline study 18 months after they have completed the course. So what we plan to do is that with this kind of data that we've obtained, we will try to estimate the impact of the technical skills training, and then also the effect of the technical skills training, or the impact of the technical skills training with the intense financial literacy skills training in addition. So that is the broad idea of what we are doing with this randomized control trial. So I think just as an overview, I would hand over back to Innocent, who will continue to speak with you about, how we used mixed methodology in this.
Yes, thank you very much, Ellie, for that introduction and background. So maybe just as a snapshot, the idea was that, so first of all, this is a heavily quantitative approach. So we have here then the quantitative baseline that was done. The intervention was started, and then we have the quantitative endline, which is scheduled for 2024. But here we have 2 midlines, and Ellie has already mentioned the first midline where we collected data, which I will refer to for illustration of analysis. There's a second one coming going on in October, and the final one will be in around March 2024. And so within this, the qualitative data has also been collected to complement the quantitative. And this is what I want to show you. Okay, maybe so let us say we had different evaluation questions. For this illustration, I won't go through all, but I want to illustrate a case on the question whether the program enrolled a certain number of people, or rather the target group. And for those, if not, why not? And also illustrate for triangulation purposes, employment and job creation evaluation question. And here, maybe just to give you again a broader overview, is that I mentioned already that it was quite a quantitative evaluation, and where the colors that you see, so this is not for you to understand exactly the project, but just to see how we mix the different methods. So this first part is more around design and data collection, and we see that, for instance, after the baseline survey, we could take that sample to support us with the qualitative sampling for the focus group discussions and the in-depth interviews. And then we see that where you see blue, this is qualitative, and where you see green, it's mixed methods, and where you see yellow is quantitative. And the green is to show you that there are some questions where both quantitative and qualitative attempted to answer. Then there's some questions where only qualitative attempted to answer, and some questions were only quantitative. And there are various reasons for this, but mainly when we are doing such design, we have to be careful and think carefully to determine which approaches to use for data collection, and which can best provide efficiency. So you think about the timing, you think about the cost, you think about the practicality. So indeed, maybe just to go back to the first question, I think from Bonnie, of course, in different cases, quantitative research could also be in position to approach certain places, but when you think about the timing, the cost, and the practicality, then you have to kind of value and weigh which approach to use. Okay, now we go to the analysis itself, and here, and this is now from the example, what did we do? So once we had the midline quantitative data, and we had the midline qualitative data, how did we proceed? So the first thing is to, of course, plan how this will be integrated. So you discuss the different expectations from the different teams. Reflect on the evaluation questions. You outline the questions and the indicators that you want to start with. Maybe you want to start with a quantitative component, just to see that you then focus on the explanations for the qualitative, and then you have to set the timeline for the analysis. So this is something that is important to do, otherwise you might end up doing separate analyses which do not speak to each other. So when we talk about reflecting on the evaluation questions and the design, why is this important? For different evaluations, especially those that take long, in mid-implementation, something might change. So your design might also change. So if you're basing your analysis on the original design, this might be problematic. So it's important to go back again and just reflect, identify what has changed, what has not changed, and how you can integrate this. Again, a certain ways of measuring change might have changed. So these indicators, again, you have to sit down together and think, so what kind of information does the quantitative have on certain indicators? Did this change? How are we now measuring it? And what kind of data do we have from the qualitative side, and which indicators do they speak to? So again, back to our evaluation questions that we're using for the demonstration. We have here on trying to see if the number of intended youths were met, and if the RISE program increased employability. And here again, in the design, we did not have, for the first question, we did not have a qualitative component, but after having some information, some analysis from the quantitative side, we integrated a qualitative part to provide some explanations, which I will show you when we talk about the results. Another thing to pay attention to then, of course, is the timeline. So once, because these are two teams with different approaches, and sometimes you have different expectations and how different ways of working. But then, of course, you're working the same project, so it's important that you sit down and reflect on the timeline, what we did for this project. Of course, and here it's important to emphasize that the project lead has to make sure that this is organized and have regular check-ins. So we started with our planning meeting, and then reflecting on the codes and the indicators in the third week after going through the data. Then we we shared some preliminary results from both sides, and which ones needed more information, and checking going back to the evaluation questions and the indicators, what kind of information we have on that, and then consolidating results and structuring the report. I must again mention that here it's usually itinerary, so it's not step by step, but it's repeated over and over again. But it's important to have a plan for the time. So and again here, then what usually happens is then you have to kind of systematize your evidence. So let's say you've been you have all your data that you've been looking at for the quantitative side, but then you have to kind of do some preliminary analysis, show how this is done. So this is done for the quantitative. I will not dwell so much on this on this, but it's just to illustrate to you that there is a system then that you go the step to systematize your data, and then also for the qualitative, you do the same. And we talked about coding before. So here, for example, if you look at here, we have the coding tree where we looked at what kind of work we wanted to do, what kind of evaluation questions we had in the beginning, and develop some code. So we needed information on training received, income. We needed on information on the quality of the training, sociocultural hindrances on gender and refugees. And again, this whole process, like I explained before, is iterative. So you have to kind of repeat it, refine it. And now we want to demonstrate the complementarity and the triangulations using certain using some of our preliminary findings. Maybe just something to note is that we've prepared this, but the whole process, this is not the final findings. The whole process is still ongoing, and some of the findings might change when we get more data. Yeah, so we appreciate that you take this, you accept that we present this as something preliminary and not final, but I think it's very important to demonstrate the mixed methods analysis and how this is usually combined. So I mentioned that we would focus on two questions. So did the RISE program select and train the intended number of youths? So at baseline, the quantitative group, of course, did some surveys, and as a demonstration, if I take this side of the graph, we see that so many people were, over 3,000 participants were selected for the training, over 2,000 enrolled for the training, and only 1,400 did the training. And for the FLES, so many, over 1,600 were selected, about 1,000 enrolled, and also a little bit over 1,000 did the training. And here there are also some something down now, maybe just to illustrate. So the quantitative has these numbers and these figures, but then something that we were lacking is, so why did so many people enroll, but only a few finished or did the training? So there were we didn't have information on that, and that's when the qualitative went back and interviewed a couple of people, especially people who did not complete or who did not even start the training but had enrolled. And there were different reasons here. For instance, the communication of outcome of selection was not done well, so people reported that they did not know that they'd been selected, or some people reported that, yeah, there were other competing similar trainings or programs with even startup kits that they didn't have, so they would rather go for those ones. But they were also disappointed with the content of the training. There were inadequate tools, and sometimes the reasons were related to the household or the cost, for example, transport. So this is how we managed then to complement the quantitative findings with the qualitative. And regarding the employability, wanted to see to what extent, what effects did the RISE program have on employability? And again, I'm not going to really dive deep into this, but what we see is that the past training, so the TSST, is the main driver of improved of being self-employable. And this also, of course, comes rather to self-perception of, yeah, am I now, do I have the right skills? And the second one, which is combined with the FLES, increased. So I'm hearing my echo. Okay, now it's gone. Yeah, so it increased the job search, especially for the male beneficiaries. And again, there were some of the questions that couldn't be answered there only from the quantitative data, and the qualitative that component looked into the material that they have. And again, yes, the talk of limited startups was very much coming up, and certain gender barriers, sociocultural barriers, where many of the women were rather confined to domestic work by different social structures, and also the decision depended a lot on their husbands. And then finally, what I want to talk about is the triangulation that I promised to share with you. And again, when we look at this again. So here, the only thing that I want to demonstrate here is that sometimes when you get information from different approaches, it might increase your level of confidence in a certain result that you have. So here we see that self-perception, like people who went through the training had a good self-perception and self-confidence in themselves and in their skills. And this led to, for example, men searching for jobs, not really starting their own jobs, but searching for jobs because they were confident about this. And in the qualitative data, we also see recurrent information regarding this, where people talk about them being more capable now, having better skills, being more confident, and that's why they go out there and actively search for jobs, because they know that it will work. So this is then how you can try to bring the two data sets together to just increase the confidence in certain result that you might have. So thank you. That was a bit longer than planned, but that's the end of the presentation. Yeah, so I see a hand. I'm not sure from Bonnie. Please go ahead, Bonnie.
Thank you so much, Innocent, for the presentation. I'm so passionate about the RISE project, especially the scheme. I directly, I would say, implemented this project in Germany with Heli here. We've always been in constant contact during our weekly updates. So I'm very impressed with the impact of the project. But rather, some of the key highlights which was being raised during the data collection, that why people dropped out or why people were not able to enroll, exactly what we have been finding out also from our data collection. It correlates well with what you have actually presented here. However, I didn't hear from your side the impact of the project vis-a-vis what I don't know how I can call it, over the difference over the impact, whereby we are looking at the treated, the impact of receiving the training vis-a-vis those who have been in the control group. How many percentage? What were the percentage of those people who have been in the control group? How many actually received it? Maybe were employed at the time of that collection compared maybe to those who received the training.
Yeah.
And also, I didn't see very well the impact of flesh on what on employment. I don't know.
Yeah. Okay. Yeah.
I didn't get
thank you very much. Those are very valid questions. Maybe I just mentioned two things for this presentation, a 20-minute presentation. We just wanted to illustrate. The point was not to share the results of the evaluation, but rather to illustrate how a mixed method could be analysis could be done and used, and that's why we took only just a little bit, a very small snapshot. We had a dissemination workshop actually in August, which was more than I think 3 hours, and we don't have that time, and it has all that information, but I'm happy to share with you a different slide. Yeah, I will have to check if this is something that is allowed already to share the different slides, but also once the results are out, we'll share. I think the Eutf will share with everyone, and finally, like I'd mentioned in the presentation, these are still preliminary results, and analysis is still going on. There's even still data collection going on, and we'll be happy to share our final results. Thank you.
Great. So I hope everybody had a interesting time so far in our sessions, was able to understand a large part of how to use the result, or how to work or understand and interpret the results from our analysis. which, at least in the case of C4ed, is generally based on CIE methods or counterfactual impact evaluation methods, right? Through this session now, our logic is to try to understand why we've been having these trainings, right? So over the past 3 years, we went step by step in first telling you about how to conduct a CIE, so kind of designs that exists and so on. The second year was more about sort of the data that you need and how you acquire clean and good data to inform your design. And finally, in the session so far, we've been trying to recreate how analysis takes place and give you an understanding of how to not only do your analysis, but also understand to some extent the results. And this session is sort of, again, leaning towards a similar focus, and it's to basically understand why we've been doing to a large extent what we've been doing and in these trainings, and to expand the idea of a CIE in your evaluations. So to recap what CIEs are, basically their goal is a counterfactual impact evaluation that is trying to expand the evidence base on whether or not programs, policies, or interventions work, why are they working, or perhaps why are they not working, right? Or why they might be having unintended effects. And you do this through quantitative and qualitative evidence, right? And the idea is that through your CIE, you will have an impact as well. So it's not just the program that is leading to an impact, but also your own evaluation from the program that also has an effect. And so if we were to map this effect out, what you would see is that first and foremost, we do a counterfactual impact evaluation, and we are able to quantify the impact from your training, right? And on livelihoods and resilience and employment, whatever variables you are interested in. With this evidence in hand, we go to our decision makers, which are, so to say, our donors who gave us the money, policymakers, which are national ministries and national governments or even regional governments. We go to program directors and tell them, this is what our program does. You know, when we find a negative impact here, we find a positive impact here, and this worked better than that. And this is basically going to help these decision makers define new policies or extend previous programs or change interventions in a way that they are based on evidence, more robust evidence, and are able to thereby be more effective in reaching their goals. Effectively, our end goal is that the population of interest is improving in terms of the outcomes of interest. And our outcomes are, of course, as we repeated several times, resilience, empowerment, livelihoods. And these improvements are what we are aiming towards slowly, right? However, through this training, we've been trying to just work on this aspect of your theory of change. We are running with the assumption that the user of these CIE, which is everyone who's working in the program, in the evaluation, is able to understand the findings from the CIE, right? Is able to understand, in the first place, why a counterfactual impact evaluation, but also able to understand and explain the results from this counterfactual evaluation. And finally, as a next step, having understood and absorbed the results from this evaluation, you are able to disseminate the results from this evaluation. Go to those donors, go to those program directors, and explain to them through the help of workshops, through the help of presentations, through the help of just infographics or briefs or even reports. Try to explain to them, this is a result from a counterfactual impact evaluation of our program. Now, knowing this result, they can do what they like further, but for you, your goal is to make the results of this evaluation clear. And that is why we spent the last day and a half going through, well, at least in the quantitative sessions, going through the understanding of descriptive statistics. Again, these are basically just to show you what kind of data you're looking at. Then we talked about how to do statistical tests to understand, to infer from your data and the differences between groups, differences, let's say, while we always talk between sample and population, but now you can also look at the differences between two samples already and use statistical inferencing to ease out the differences between those. And then finally, we used a slightly more refined tool, such as regression models, to be able to understand what the impact is of one variable or one program or one set of information on our variable of interest, which again could be employment or whatever, right? And knowing these three things, we basically are able to now hopefully understand the output that are displayed or are depicted in our CIE outputs. Traditionally, as I said, through reports, through journal papers, through presentation, through briefs. These are the various media we use for communicating the results, and you hopefully are able to better understand what these results mean. And again, this session is able to go through this part of the reporting process again and ensure that this aspect is clear. Naturally, only when you've understood this well and are able to explain it well can you draw good conclusions and etch out valid recommendations from these outputs, right? So again, what I've previously also already mentioned, what is a descriptive statistic? It is basically simply able to tell you what the characteristics of the participants of the program were. So what is their average age, whether they are female mostly or male mostly, what is their average level of education, where they stem from, urban or rural communities, what is their income level. And with this in hand, or an idea of what your sample at least looks like, which hopefully is representative of your population, you are able to understand, is this the context that we were initially meaning to work in? Have we reached the right people? Is this the population of interest? And if yes, can we generalize this result to a larger population? And this is the question of generalizability of your program, especially when you're trying to scale up your program. So often programs have are piloted somewhere, and then they need to be scaled up. And so it's important for you to understand whether these results are generalizable across various other contexts as well. So to just briefly talk about this table that I'm presenting over here, right? What we see here is, and I hope everybody can see it because it's quite tiny, but we have again the same three columns. We have the full sample, we have our treated sample, and we have our comparison sample, right? So this is the group of individuals who was, or this is our group of number of individuals who were in the program. These were those who are not in the program. Again, CIE or counterfactual impact evaluation methods always rely on a comparison. So we do need these two groups in our entire sample. And now what we are able to see, at least for the whole sample, is that the average age is about 25 years for our sample. So if we were to now go to another county where the average age of participants is 35, the context is differing and maybe the results will differ. What we also see is in our program, we managed to acquire 50% participation from females. Is this one of the program goals? Did we want more? These are also questions that your descriptive statistics can help you answer. And how do we do that? We always rely on measures of central tendency. So this is sort of what we were talking about in session 2, right? So besides showing us your mean and median, which is derived through the averages, you also need to understand what is the dispersion in your data. And that, for example, in this particular case, is represented by these numbers right underneath your mean, right? These numbers are effectively the standard deviations that you have for your value. Again, This is just the dispersion of your data. There are variables, for example, such as age, that are not likely to be very dispersed. You're generally going to find the youngest individual in your sample is probably still above 18, whereas the oldest, because it's a youth training program, is potentially no more than 40, right? So this is not such a widely dispersed sample. However, income, on the other hand, another variable that we are interested in, can be extremely dispersed. You have some people with no income and some people who are earning in the hundreds of thousands even eventually. And so these are variables that, or this dispersion is also something that you should understand and be able to point out in understanding why your values in your mean might not be so reliable. Again, think back to our example of the very high of our income of 885, where our program goal was to reach 800, but due to the extremely large standard deviation, we knew that there were outliers or very vastly lying values, which mean that we were not very close to representing the entirety of the population with one number, one mean, right? So we have to take care of these outliers. We have to see why our dispersion is so large and try to understand whether the mean that is being reported is actually a valid or a true mean. Then the second thing we talked about is inferential statistics, and that is to see where we were always generally talking about these differences between sample and population. And while this difference is something also that we face systematically, what you would notice in your reports is another difference that we are testing, and that is the differences between two samples. And specifically in this case, the sample being the treated sample versus the comparison or the counterfactual sample. And for example, if you remember how it goes in statistical testing, our null hypothesis is that there is no difference between these two samples. What you have to do now is create a test. Traditionally, we always use a t-test, and derived from that t-test, you're able to get a p-value. And with the help of the p-value, you can define your significance level or confidence level with which you reject your null hypothesis. The first cell here that I've marked in red now is the basic difference between the two means. So for example, in terms of age, you can see here that on average, or the difference is 0.5 years, or about 0.4 years, or about 0.5 years, which is half a year. And what we see is that on average, our treated or our program participants are about half a year older than non-participants. So we are indeed looking at a difference between our program participants and our non-program participants. Finally, in the last column that you would see, where again we're talking about balance tests or balance tables, sorry, we have a secondary value underneath our difference in mean, and this here is not the standard deviation as here. Rather, this is now reporting your p-value. Always p-value is a proportion or a probability, and to be able to compare it to your significance level of 5, 1, or 10%, you just have to multiply it by 100. As long as it's below a particular significance value, you can accept or you can reject your null hypothesis and say that there are, for example, in this case, differences or statistically significant differences between your two samples. So this difference of half a year is legitimately existing in your sample, and you cannot say that your null hypothesis is true, or you cannot say that both samples are similar in age. In this case, the p-value is 0.07, which means that you have 93% confidence that your results are not due to chance, but this are statistical, or these are statistically significant at 7% level, or at least at 7% level. We also talked, at least in the case of the Ethiopia sample, about the stars. So here was sort of the note, or here's the sort of note that you always see in the bottoms of some of these CIE methods, wherein you have one star 2 stars and 3 stars, the more the number of stars, generally, if it's shown as stars, the better your or more confident you can be in your results. With the first 1 star only the 90th percent confidence level, the 2 stars being 95% confidence level, and the 3 stars being 99% confidence level. So in this case, you do see that we have 1 star, which means this is we are confident at the 90% only, right? So our reports will sometimes say that this is weakly significant result, because as we get closer to 90%, it becomes weaker, and the closer we are to the 99%, this is a very strong result. So results which have more stars are traditionally the ones that are very reliable, and where we can be sure that our statistical testing is giving us a solid result, and there is very little likelihood of this being due to chance and not due to actual, or this being the true estimate. So in our case, what can we conclude in terms of the difference between participants and non-participants? To put it very simply, it's to say that there is a difference between our treated and comparison group. And again, the treated group here is older. Again, that's largely because you see the positive sign here, no negative sign, and you always subtract this from this. So you're always taking column 3 away from column 2, right? So this is the larger value. Again, if you have to interpret this, don't know what you're subtracting from what, just look at whatever the larger number is, and then you know which one is the one that you're subtracting from. So in this case, there is another the variable or coefficient that we are interested in, and this is now, let's say, the returnee, exactly, the returnee status in our sample. So what we see here, for instance, is that this value is 0.07. In our treated group, we have 12% returnees, or sample is returnees, whereas in the comparison group, only 5% is returning. Again, to interpret this, just simply multiply by 100, because we're talking in proportions which lie between 0 and 1. The difference is implying that with 99% confidence, we can say that the difference between the two is 7 percentage points, which is to say that our treated group has more number of returnees, or more proportion, sorry, of returnees than our comparison group. Right. So I hope this bit was a little clear. And then we move on to basically asking ourselves a question on what does this imply, or what does this column imply to us about the differences between the two samples. If one were to look at all of these numbers, you see that there are several stars here. And again, this is sort of the balance table showing you the difference between the two groups at baseline, right? So before the program has started. So this implies that at baseline, we have differences between our sample. These two are statistically significantly different from each other. Of course, for a varying level of confidence, but there is a difference here. And in this particular case, which I believe is from Gambia, I think this is the Gambia Eutf project, what we saw was that there was no random assignment of individuals into the treated and comparison group. So what we had to do was use a quasi-experimental method, and in this case, it's either propensity score matching or Gaussian exact matching, but we have to use matching. And so basically in our sample, find individuals who are similar in characteristics, and then try to understand what the impact of the program is, right? So just to give you an indication as to what this non-random assignment did, just look at this column, right? So this is the interview score between the two groups, and I really hope you can also see it. What it says here is that in the full sample, the average interview score was 15.5. For the treated group, however, it was 16.4, whereas for the comparison group, it was 14.3. So technically, there is a difference of 2 points between our treated and comparison group, with there being higher points given to the treated group. So these are systematically different individuals at baseline. Again, remember what we talked about before, that if there are systematic differences between your treated and your counterfactual group, these are not good comparison points, right? Now, let's to give you just a very basic intuition of how coarse exact matching works. So first, you look at the darker points here. And this line in the middle is just telling you whether they are different from each other. So any point that is closer to this line is generally good, right? So if you look at all the dark green points, they are further away from this line. And this is an indication of whether or not they are different from each other. So so what you see here, for example, this value, which is the returnee status, is far away from this line. Again, this was a result I showed you where you saw that there were many more returnees in the treated sample than there were in the control sample, right? Or similarly, here you can see that those who applied for the satellite insurance are also very different from each other, so between the treated and control group. And again, here it appears that actually there are fewer individuals who applied for satellite insurance. I'm not sure what this variable actually means. And this is what they look like. Here, another interesting thing that you can see is the confidence intervals. So if you look at these dashed lines, these represent a certain amount of confidence interval. This, I believe, is the 95%, and that probably is the 90% confidence interval. No, sorry. The further away you are, this is the 99%. So the worse it is, right? So the further away you are, the more likely you are running into issues of confidence interval. Anyways, the second, what would happen, what we did after matching. So we now took, this was the entire sample, and this is what it looks like, right? After matching, what we find is these light blue points. Most of them are on the line, which means we've managed to make both groups similar and reduce the differences between the two groups to 0. Of course, there are still some differences, but as long as they are closer to the 0 line and closer to the smaller confidence intervals, the more weakly or the less confident we can be about these differences, right? So they could be different or they could not be different. And that's what matching has managed to achieve in this example, particularly, just to explain this graph. I see that Bonnie has raised his hand again, or would you like to, is this about the matching?
Yes, Pasha. I just wanted you to explain to me. It's very interesting. Number of children at above 10 at baseline and number of children above 10 at baseline. What were we looking at? Were we looking at the impact of the project on birth? I don't know, because I think we're looking about number of children at baseline. What was the question you're interested in?
Yes, you mean here, this one, right? So number of children above 10 at baseline and below 10. So again, this is often a indication of dependency in a household, because in certain contexts, already children who are above 10 are expected to bring in some money. So I think this is one of the variables that you try to understand whether these are different within households, because this can be considered as someone who's earning an income. Not legally allowed, but is the reality in some of our contexts that we are working in. So if I was to just look at these two coefficients, what you see here is that actually they are not very different in the control or the treated group. So probably since they're within these two lines, you can see that they are likely not statistically significantly different from each other. What you well brought up is this new dot, right? So after matching, what you observe is that the difference increase, at least for the case of number of children above 10 at baseline. So now the matching has resulted in a larger difference in the in this variable between the two groups. Likely still not statistically significant, maybe actually still, I mean, I don't have the results right in front of me, but it's on the line of confidence interval, or the lower bound of the confidence interval. So yes, but it appears that it has brought about a bit more discrepancy, but the overall idea of matching is that we get most points on this line. And if some are therefore moving away, and for example, these are the two cases that I can see that they are moving further away than the original value, that is a sort of compromise that you're willing to make so long as most other differences are removed. Okay, so I wasn't expecting to take that much time on this graph, so let me quickly, I hope that answered your question. So the next aspect that I wanted to talk about is now what happens when right, so this was the original balance table that I was showing you, right? Now, or not the original, there was a original balance table that I was showing you. Now, if we were to use the matching method, and not necessarily, as I said, we didn't use random assignment here, but we use a matching method to change or to define our sample, what we see is several of the differences that we originally saw have disappeared, right? So our sample is only different in terms of the number of female respondents, while everything else, all of those additional stars, all of those differences that you were initially seeing have disappeared. And this is sort of the role of CIE in trying to minimize the differences between program and non-program participant comparisons, right? So I hope with this you can at least, thinking back on the initial table I was showing you, you can see that a large number of the differences that we initially had have been reduced. Our matching or potentially our randomization was successful in removing the differences between our two samples, which means we have a comparable sample. We can say that as a result of this comparison, we know that the results of the program are caused by the results of the or the differences in income, differences in employment are caused by the program, are only attributable to the program. Not the fact that one group is more educated, not the fact that one group was starting with more employment in the first place, but are comparable at the start, and therefore results we see at end line are because of the program itself. So I hope that was able to help you understand what the evaluation is helping you get. What you would see in your reports, however, is the impact estimate, right? This is what tables generally in your report look like. So some of your reports, some of these are actually even from the Eutf project, and what you would see is what was the impact on on enrollment? What was the impact on unemployment? What is the impact on unemployment? So generally your variables that you're trying to explain the impact for will be on the extreme left, generally, or will be given somewhere. And then you will have several other aspects here. And I will try to now go through it on what the common ingredients of these tables look like. So in the first place, remember we talked about measures of central tendency to be able to describe your data, right? As well as measures of dispersion. So the first column generally tries to give you an impact. It might be based on a measure of central tendency, so you're just looking at absolute numbers. What is an absolute number in this case? So if I was to define what something is in absolute numbers, it would be months in employment in the last 6 months. So what you see here, for example, is that in this group, well, here there are no differences because you see no stars, but there is no, let's say, effect on the months in employment. But overall, this is a absolute value. whereas there are others that are presented in a relative terms. So this, for example, is something that is a percentage point increase, which means there is a 15 percentage point increase in the number of people who claim they have a job in the last 7 days. Again, this is statistically significant because you can see with the stars. So this is the third point that is referred to here, and so on. So you can now hopefully use the measures of central tendency, whether it's a relative increase or an absolute increase, in order to understand what the first aspect looks like. Then the second, sort of underneath the coefficient, you would see these numbers in brackets, which are basically your measures of dispersion. Traditionally, they are either standard deviation or standard errors. When looking at regression, I would say they're generally, or usually people present standard errors. Sometimes a t-statistic, but mostly standard errors. Then the next thing you will see is, of course, the reference point. Now, in our initial example, it was, for example, your comparison group. So when you take your treatment group and you take your comparison group, your estimate is always against the comparison group. So in this case, the POM, or the potential outcome mean, in this case, ignore the title, is just showing you what the mean is in your comparison group. So to explain just this coefficient, it means that, 56% of your comparison group claimed to have had a job in the last 7 days. All you have to do is sort of add this coefficient to it, because it's a percentage point increase, to understand that actually our treated group, or those who received the program, were at 71% claiming to have had a job in the last 7 days. Again, the stars that I've already repeated about, so I'm not going to tell you. It's simply an indication. So that you see no p-value here. It's because the stars are doing the job for you. You know that it's significant at the 99% level. Generally, the table will give you sort of an indication of what the stars represent, so that you don't have to really worry about it. And then finally, there will be the type of effect you're looking at. I sadly don't have the time to go into that, but there will be at most 2 types of effects that you will be looking at. So first is the ATT or the ITT. And the difference between the two is, very simply put, the ITT assumes that you've been exposed to the program and that you've received some exposure to the program. And in the ATT, you know you've received the program. So this, you know that the person you're interviewing has received the program, and here you assume they have received the program. So these are the differences in estimates. Generally, this is more, how do you say, a real world scenario, because you are not able to, like when it's a national program, for instance, you're unable to see who actually benefited from it versus who was exposed to it and may not have benefited from it. So these are the more real world estimates, whereas these are the estimates where you are able to fully control who is getting how much when. Right, so based on this, hopefully you are able to draw initial conclusions on what has happened as a result of the program. A few very quick things to consider when interpreting your impacts. First is the effect sizes. So let's say you get a p-value that is under 0.05. Again, remembering your significance level, you say, yes, I have a result. It's confident. I'm confident that there is a difference in my treatment group, that I'm confident at the 95% confidence level. But it's important to consider what this effect is, or what the p-value is representing, right? In our example, let's see that the income level in the treated group is 1,002 units, whereas in the control group is only 1,000 units. So actually, in absolute terms, you've only managed to increase through the program your result by 2 income units. This is really nothing in terms of an impact, economic impact. Sure, you see a statistical impact, but when considering whether or not to scale up your program, or whether or not to think about if this had an impact, consider whether or not your effect size is economically worth it, whether the millions of euros or dollars that you've invested into the program have led to a sizable impact. So this is an important consideration when you're looking at your tables. Is this a big enough impact, right? Please remember, this is a hypothetical example I'm giving you. I hope it's not the case in your evaluations that you only see a difference of 2 units in terms of income. So it's important to consider effect size in effectiveness of the program. The second thing is internal validity, which is to say, are we confident that whatever we are measuring is actually the true estimate? Now, we've been talking about the true estimate through statistical error, through sampling, through many other aspects, right? So whether it's generalizable to your population, now these are the various true estimates we're talking about. However, if you remember, there are problems that your own design might create, and these are internal validity issues. So for example, did you design your counterfactual impact evaluation in a well enough way that your control and treatment groups were comparable? Did you ensure that the group you selected as your counterfactual has not been compromised? Did you sample well enough from both groups, or did you take perhaps the wrong set of people? And of course, is your data reliable? So these all are factors that compromise the validity of your evaluation. And these are factors that are internal to your design and your evaluation and compromise the evaluation itself. So the internal validity is something that you have to be confident about. And if there are issues in it, you need to really talk about them and to be able to ensure that your results are not necessarily biased or incorrect or not true, right? Another aspect to consider is external validity, and this is actually quite relevant for all of you, because your eventual goal is to understand if your program worked and if I can now take this program and bring it to another context and will it work. So generalizability is another word used for external validity of your results. So if I was to take my program and just scale it up nationally, will it work? And this is something that you need to understand through your descriptive statistics, for example. Am I only looking at a very specific type of sample, which is very different from the national sample? And these are the kind of decisions that you need to be able to think about, rely on your descriptive statistics in order to understand how you can externally validate your results as well. Again, if you're not doing the evaluation yourself, ask your evaluator to consider this in their reporting. And as I said, there's a trade-off between internal and external validity. Sometimes when you try to do a very internally valid design to make sure that the design of the evaluation is completely correct, there's no wrong problems in sampling, and the data is wonderful and clean and brilliant, and it would not fit into a real world scenario. When you get to the real world, there'll be so many messes and so many external factors that your external validity is compromised. So there needs to be a trade-off, and you need to understand that trade-off when you work with CIE. And with that, I end the session.
Hi, everyone. So I'm not sure if everyone is back. We shared the questions for the breakout room discussions. Maybe I'll just share my screen briefly, but this is just it's a task that is supposed to be looked at as a group, just to go over certain things we've talked about in the past few days, that is yesterday and today. What we are going to be doing is that we have some of our colleagues from C4ed who will join you in the breakout room to help you with some of the discussions. So the idea would be for you to go through the tasks. There is a preamble, and then followed by some tables that we would want you to look at, and then try to answer the questions that follow up. And then there is an answer sheet that was shared with you. The questions were also shared with you by Caroline. So my colleagues will join you and then go through the different parts with you. So ideally, it would be good for you to choose someone who lead your group. My colleagues are only there to help you in case you're having any difficulties. Type in the answers into the sheet. If anything is not going on well, if some of the responses are not correct, they would help you out and try to, like, you know, help you look at the tables and then come up with the right responses. Okay. Thank you very much. So I will move you to the breakout rooms right now. If anyone does not have a room, please let me know, and then I will work on this.
Yes, it's actually the end of the workshop. I think it was, I actually was not in any of the sessions, but I assume it was exciting for the participants to then be able to use the knowledge from the sessions during the breakout session, and we're able to maybe even implement all the knowledge in these two sessions. So on the closing stage, I think there are two things. First, I think there is a short feedback session again for the second day that Ellie will help me launch, or Ellie will launch and conduct. And after this, I think just a final set of goodbye words from our side. Well, in that case, I'll take the opportunity to send out a short round of thank you. It was extremely interesting for me, at least in this session. All throughout the sessions, it was encouraging that there was some nice feedback from you, at least in the chat, about the facilitation and about the entire content of the session. Please note, we will definitely be sending you the slides. I also really hope that everyone takes out the time to go through the slides. We are also very happy to receive just independent feedback from you, which would be helpful for us to prepare better for the trainings next time. I'm aware that we have covered a lot of ground, a lot of very complex ground in one go, in a very short time period, maybe not allowing every participant enough time to absorb this content that we have shared, but through the slides, at least, I hope that you will be able to go through it at your own pace, and then always receive look through the recordings to be able to recollect what we talked about in the sessions itself. So there are resources that should hopefully allow you to go through the material at your own pace if you're interested and following through with this session in general.
Thanks, Eutf. Thanks a lot also from my side. For me, it was a pleasure to leading this trainings this year as well. And yes, as already mentioned by Attica and Eutf, you will receive an email where we will share with you the slides from day 1 and also from day 2. And please feel free to share it with all your colleagues or people you think they will be also interested in. Then we will also share with you the link to the recordings after they have cut together, and will be uploaded at the Eutf website. And you will also have the possibility to get certificates if you have participated in both of the training days. But all the information you will find in the email we will share in the next days with you. That's all. Next week we'll have the same sessions in French. So if you have colleagues in French, please recommend it to take part, and let me know if I should forward the invite to some of your colleagues. And I wish you a good rest of the week, and hopefully see you next year then. Thanks a lot.